Now that we've covered most of the PowerShell basics, I want to spend some time talking about how you can use PowerShell to interact with the Active Directory. A lot of the day-to-day administrative tasks that almost all organizations perform are directly related to the Active Directory, so I want to show you how to use PowerShell to create, query, modify, and delete Active Directory objects. In Lesson 6, I talk about querying the Active Directory, creating user accounts, modifying user accounts, and work with Active Directory groups. Hello and welcome back. This lesson is all about using PowerShell to interact with the Active Directory. Now, throughout this lesson, I'm going to be showing you a number of different techniques, but it's worth noting that I'm really only going to be scratching the surface. My purpose here isn't to give you a comprehensive discussion of everything that you can do as it relates to the Active Directory, but rather to introduce you to a few fundamental concepts. There's a chance that at some point in the future I may create an entire course out of using PowerShell to interact with the Active Directory. The topic is that vast. So I'm certainly not going to be able to cover everything here, but I want to at least give you a taste of what's possible. So with that said, let's go ahead and jump in and get started. Now, the first thing that you need to know is that everything that I'm going to be doing in this video requires you to either be logged in directly to a domain controller or to have the Active Directory services installed. So let's take a look at how that works. I'm just going to go ahead and click on the Start button. And then from there, I'm going to open up Server Manager. And in this case, you can see where my mouse is that something called ADDS is installed. That's the Active Directory Directory Services. So that's the required component that I was talking about. If you don't have this installed and you're not working on a domain controller, it's easy enough to install it. What you would do is go up to Manage, and you could do this with PowerShell too. I'm just going to go ahead and use Server Manager. But you would go to Manage, and then you would click on Add Roles and Features. And this is going to open up the Add Roles and Features wizard. And so then you would click on Next, 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 and then you come to the screen that asks you to choose the server roles that you want to install. And the role that you would install is the Active Directory Domain Services, which I've highlighted right here. And then you would click on Next a few more times, and the required role would be installed. Now, once that role is installed, you're going to see this warning icon right here. And if I click on this, it indicates that there are some post-deployment tasks that are required. And you can see that Windows wants to promote the server to a domain controller. Now, you don't have to promote the server to a domain controller. If anything, I would recommend that you not work directly from a domain controller. The only reason why we're getting this message is because all of the required components to use the server as a domain controller have been installed, but we don't have to convert the server into a domain controller. So with that said, I'm going to go ahead and close out of this. And let's go ahead and switch over to PowerShell. And I'll clear the screen. Now, the main command that I'm going to be using throughout this video is get-aduser. And what this commandlet does is it retrieves information about Active Directory user accounts. If I press Enter, we're prompted to enter a filter. That's one thing that makes this particular commandlet a little bit different from some of the others that you've seen, is that it really needs a filter in order to work properly. I'm just going to enter asterisk as the filter and press Enter. And you can see information related to all of the different Active Directory user accounts. So for example, here's a user account. We can see the distinguished name for the account. We can see that the account is enabled because we have a value of true in the enabled field. We can see the user's given name. We can see the username. We can see the object class, which is user. This is a user object. We can see the object GUID, the security account manager name, the security identifier for the user. In this case, I don't have a last name or a surname assigned, but if I did, you would see it right here. And you can see the user principal name. Now, the main thing that you need to understand is that this is just a representative sampling of some of the bits of information that you can pull out of the Active Directory regarding a particular user. There's actually a tremendous amount of additional information that's available to you. And I'm going to show you how to access that information as we go along throughout this video. So before I do, let me go ahead and open Server Manager back up. And now that Server Manager is open, I'm going to go to Tools, and I'm going to go to Active Directory Users and Computers. And I'll go ahead and close out Server Manager and make this a little bigger. So here we have the Active Directory Users and Computers console, and I apologize if this is a little bit small. Right here we have a listing for our domain, and I'll go ahead and expand this out, and there's a container called Users, and this is where all of the user objects reside. Some of these user objects were created automatically. You can see that we have a number of security groups that were created automatically by Windows. We also have an administrator account and a guest account that were created automatically. But then we have all of these accounts right here that I created ahead of time. And rather than just come up with a bunch of fake names, I just called my user accounts user 1, user 2, user 3, and so on and so forth. We have 22 user accounts in all that I created. So let's take a look at one of these user accounts. I'll go ahead and open up user 1. So what you're looking at right now is the user properties dialog box. And this dialog box contains various attributes for the user. So in this case, the user account is an object, and then we have attributes that are assigned to that object. What kind of attributes? Well, we have the user's first name, their last name, their display name, a description of the user, the office that they work in, the user's telephone number, their email address, a web page, and then we have a number of other tabs that also contain information about this user account. If I click on the Organization tab, for example, you can see the job title, the department that the user works in, and if it were populated, the company that the user works for, the user's manager, and down here you can even see the direct reports. Because you can see that the user's job title is General Manager. So as a General Manager, this particular user is going to be in charge of some other users. So user 3, user 4, and user 5 are the users who report directly to this General Manager. Now this brings up an interesting point. The techniques that I'm going to show you assume that these various attributes within the Active Directory are populated. In a lot of organizations, admins will just do the basics for setting up user accounts, but they won't bother populating these various fields that exist. From a PowerShell perspective, the more information that you put into the Active Directory, the more useful PowerShell is going to be, especially as it relates to querying user objects. And there are all sorts of fields that we can populate. I showed you the Organization tab and the General tab, but you can see there are a lot of other tabs. The Address tab allows you to enter a street address for the user. We also have the Account tab that pertains more to the user account, and it contains information related to that. There's a Telephone tab where we can put in a number of different phone numbers for the user. Incidentally, this particular user has a phone number assigned on the General tab. And then we have other tabs such as Session or Environment, Dial-In, Member Of. So some of these particular tabs relate to the user's job function. Others just relate to more logistical type things that have to do with the user account and how that account works with other objects within the organization. So let me go ahead and close this out. And let's begin taking a look at a user object. So I showed you the get-80user commandlet, and you saw that it spewed information about all of the different users in the organization. Now, incidentally, when I entered this commandlet, I entered get-80user by itself. And then when I pressed enter, it prompted me for a filter. And I typed asterisk, and that's how I got all of that information that you saw. Now, we don't have to wait for the get-80user command to prompt us for a filter. We can simply append the filter to the commandlet. I could do something like this, -filter, asterisk. And if I press enter, I get the exact same thing that you saw a moment ago. Now, one of the problems about querying Active Directory information in this way is that we get a ton of information that's given back to us. So let's say that we wanted to narrow this down a little bit. We can easily do that by using the select object commandlet. So let's take a look at just the user names. So what I'll do is I'll repeat the exact same command that I just entered, get-80user-filter asterisk, and then I'm going to append a pipe symbol, followed by select-object, and then name. And I'll press enter, and this will give me the name of all of the Active Directory user accounts. Now, as I scroll through here, you can see that some of these are accounts that I've created, the user 1, user 2, user 3, and so on. And then some of these are built-in user accounts, things like administrator and guest and so on. So what if I wanted to filter out the built-in accounts and look only at the accounts that I've created? We can very easily do that. The fact that all of the user accounts that I've created follow a standardized naming convention, user 1, user 2, user 3, and so on, actually makes this just a little bit easier. So let me go ahead and clear the screen, and I'll repeat the same command that I just typed. Get-80user, filter asterisk, select object name. So what I'm going to do is change the filter. Now, right now, the filter is set to asterisk, and asterisk is a wildcard value. It means that you want to look at everything. So I'm going to backspace over the asterisk, and I'm going to create a custom filter instead. So I'm going to enter a bracket, and then name dash like, and then a quotation mark, asterisk, user, asterisk, quotation mark, and bracket. So now we've got a custom filter. So what are we really doing here? What we're doing is we're looking for any user who has the word user in their username. And that's where the like operator comes in. You'll notice that when I set up the filter, I have an asterisk in front of the word user and behind the word user. So that means we're going to look at any user account that has user in the name. It doesn't matter what comes before a user or what comes after a user, because remember, we have usernames like user 5, user 6, user 7. PowerShell is going to ignore those numbers because we have these asterisks right here. We're just going to look at any user accounts that have the word user in the name. So if I press enter, you can see those user accounts. Now, incidentally, I had to use the operator like when I did this, because we're looking for users with a username that's like something containing user. If I change this to equals, we're not going to get any results because we don't have any user accounts whose name exactly equals the word user. So you can see when I press enter, we didn't get any results. So I'm going to change this back to like. And there's our list of user accounts. So now that I've shown you how to retrieve a list of user accounts, let's take a look at one specific user account. I'll type get-80user, and let's look at user 1. Then I'm going to type -properties, and let's look at this user's department and their manager. And then I'm going to pipe that into select-object, name, department, and manager. And hopefully I haven't made any typos. And you can see that user 1 is an executive, and this particular user doesn't have a manager because they're at the top of the organization. So let me pick a different user account, somebody who actually will have a manager. I'll just pick a user at random. How about user 15? So now we can see user 15's username. We can see that they work in the finance department, and we can see that their manager is user 5. So we're able to get this type of information out of the Active Directory using PowerShell. Now, one thing that is important to keep in mind is that we really are pulling this out of the Active Directory. The information that you see presented right here should match up with what appears in the Active Directory. As a matter of fact, let's go ahead and confirm that. I'm going to click on the Start button, and I'll open up Server Manager. And I'll go to Tools, Active Directory Users and Computers, and let me close out Server Manager. And the user that we looked at right here was user 15. So if I switch over to Active Directory users and computers, let me find user 15. Here it is. Okay, so user 15 works in the Miami office. And if I go to the organization tab, we can see that they work in finance, and our PowerShell results indicate finance as the department. The user's manager is user 5. And if we look at the manager category in Active Directory users and computers, we can see that user 5 is indeed user 15's manager. So the information that we're extracting from the Active Directory using PowerShell is identical to the information that is presented in Active Directory users and computers. Now, it's worth noting that for the purposes of this video, I'm just using get-80user and I'm pulling information out of the Active Directory to display, but these attributes aren't read-only. Assuming that you have the necessary permissions, you could just as easily put information back into the Active Directory. We could modify any of these attributes, we could populate empty attributes, and we can do every bit of that from PowerShell. But with that said, I'm going to go ahead and close this out because there's a couple of other things that I want to show you. And let me go ahead and clear the screen just to reduce the clutter a little bit. So what if we wanted to take a look at attributes such as the department and the manager for a number of different users? Well, we could do that just as easily as retrieving that information for a single user. So let me repeat the command that I just entered. In this case, I had get-80user, user15-properties, department, manager, and I piped that into select object name, department, and manager. But we can easily modify this command so that it looks at all of our users instead of focusing on a specific user. So what I'm going to do is to add a filter. And I'm going to put that filter in place of the username that exists in the command right now. I'll use asterisk as my filter. And I'm going to leave the properties set to the way that they are. And I'll press enter. And we can see all of that information from our Active Directory. So we see each user's department, and we can see their manager and the username. Now, if you look at the very top of the screen, you can see that we're pulling in those built-in accounts instead of just the accounts that I created. So what if we wanted to modify the command to get rid of those built-in accounts? And when I say get rid of, I don't mean delete those accounts. I just mean hide them so that they're not included among the results. Well, we can do that with a custom filter. So I'll just repeat that same command that I already entered. And what I'm going to do is replace the asterisk in the filter with a custom filter. And this is going to be very similar to what you saw earlier. So I'll backspace over asterisk, and I'm going to replace this with name dash like quotation mark asterisk user asterisk quotation mark bracket. And assuming that I haven't made any typos, we now get a list of just the user accounts that I've created, not the built-in accounts. Now, there are some other ways that we can look at the data. We're not limited to simply looking at usernames, departments, and managers. There are a number of other things that we can look at as well. So what if we wanted to take a look at users based on what department they work in? Well, we can easily do that. All we have to do is change the filter. So you'll notice that we have users working in various departments. We have executive department users, IT users, marketing, and finance users. So let's take a look at just those users who work in finance. I'm going to type get-80user, and I'll type dash filter, bracket department, dash EQ, and that's equals, quotation mark finance, quotation mark, bracket. And the reason why I'm using equals here, whereas I used like earlier, is because I'm searching on a literal value. I'm searching on the finance department. I'm not searching on variations of the finance department. So then I'll type dash property, and I'll use department, manager. And I'll add the pipe symbol and select dash object. And I'm going to use the same select object command that I used earlier. I'm going to enter name, comma, department, comma, manager. And I'll press enter. And so now we see only those users who work in finance. And for each one of those finance users, we see the username, a confirmation that those users do indeed work in finance, and we see who the user's manager is. So how else can we break this down? Well, we see that all of these users work in finance, but what do they do in finance? Let's take a look at the user's title. So to do that, I'm going to repeat the same command that I just entered, get-aduser-filter department equal to finance, -property, department, comma, manager. And I'm just going to add title to the list of properties that we're using in this command. And I'll add title right here. And I'll press enter. And I made a typo somewhere along the way. So let's see what I did wrong here. We have get-aduser-filter department equals finance, -property, department, comma, manager, comma, title. And then we have a pipe symbol, select object, name, comma, department. I have a stray comma here, so let me get rid of that. And let's try this again. And so now I see the username, the user's department, their job title, and their manager. And we could even build on this a little bit more. If I wanted to, I could add in the user's office. So I will add office to the list of properties. And I'll also add office to the select object command. And when I press enter, you'll notice that the information is still being output as before, but the formatting of the information has changed. And the reason for that is that the default format is the table format. But we're outputting so much information for each user that it isn't really practical to include all of that on a table. So PowerShell automatically reformatted everything into list format. So that's why we see everything presented the way that it is here. So with that said, let's go ahead and narrow this down just a little bit. Let's go ahead and take out the user's manager. And we don't technically have to remove manager from the list of properties, but I'll go ahead and do it. And so now we see the username, the user's department, the office that the user works in, and the user's title. So we have a lot of good information here. So what if we wanted to filter out this information based on where a user works? What office do they work in? Well, let's take a look at all of the users who work in the Miami office. The way that we would do that is by typing get-aduser and then -filter. And I'm going to set this office -equals Miami. And then we'll go with the same properties that we looked at a moment ago. And I'll press enter. And you'll notice that we have an invalid value in the office column. And I see right away that the reason why that happens is that I made a typo. I left the E off of the end of office. So let me go ahead and fix that. I'll press enter. And so now we see the usernames. We see that all of these users are in the Miami office. We can see what department they work in and what their job title is. Now, one last thing that I want to show you is that you can use compound filters in PowerShell. Now, what do I mean by compound filters? A compound filter is essentially just filtering on multiple items at the same time. Right now, the only thing that we're filtering on is the user's office. We're looking at all of the users who are in Miami. But what if instead we wanted to look at all of the users who are in Miami, but who also work in the IT department? We can very easily do that just by adding a secondary filter. So let's go ahead and wrap up the video by doing that. I'm going to repeat the exact same command that I just typed, and I'm going to backtrack to the filter section. I'll add a space, and then I'm going to add -and. So -and is another operator. So this tells PowerShell that we're setting up two conditions and that in order for an item to be displayed among the results, both of these conditions have to be true. So we have our first condition, office equals Miami. And for our second condition, we're going to set department equals, and then we'll set that equal to IT. So our first condition is that office equals Miami. Our second condition is department equals IT. And so the only results that will be displayed are results that meet both of these criteria, IT workers in Miami. I'll press enter, and here's our results. So user 3, user 8, user 13, and user 18 all work in Miami and are all members of the IT department. So that's just a quick taste of some of the ways that you can display information contained in the Active Directory from within PowerShell. Hello and welcome back. In the previous video, I showed you how to use the get-80user commandlet to examine user accounts in the Active Directory. In this video, I want to switch things up just a little bit, and rather than just looking at user accounts, I want to show you how to use PowerShell to create user accounts. And in doing so, I'm going to be using a few different techniques. Now, one thing that I want to quickly mention before we get started is that the techniques that I'm going to be showing you aren't the only ways of accomplishing this. There are endless variations on the techniques that I'm about to show you, so certainly my way isn't the only way. But I'm going to be showing you what works for me. So let's go ahead and get started. Now, as you may recall, I've got a lab-based Active Directory environment, and I've got a number of user accounts that I created. And rather than coming up with a bunch of fake names, I just named my user accounts user 1, user 2, user 3, user 4, and so on and so forth. Now, to get started, I can't remember exactly how many user accounts I created. I think it was 23, but I'm not positive. So we need to find out how many user accounts we've currently got so that we don't end up duplicating what's already there. So let's go ahead and take a look at our existing user accounts. And to do that, I'm going to repeat a technique that I used in the previous video. So I'm going to type get-80user -filter bracket name -like quotation mark asterisk user asterisk quotation mark bracket, and then I'm going to feed that into the pipe symbol and select -object name, and I get a list of my users, and it looks like my most recent one was user 22. Now, interestingly, because we are numbering our user accounts from 1 to 22, there is another way that we could get this information. I mean, this is really easy, looking at the screen and saying, okay, the last user is user 22. But what if I had hundreds of users and they weren't in order like this? Well, we could actually count this using a very similar technique. What I'm going to do is repeat the command that I just typed, and then I'm going to go to the beginning of that command, and I'm going to declare a variable and set that variable equal to this command. So I'm just going to type $A equals, and then get-80user filter name like user, select object name. I'll press enter, and we've set $A equal to that command. So if I were to type $A, then we get that same list that you saw just a moment ago. But I mentioned that there was a shortcut to counting these users. So here's how that shortcut works. What I'm going to do is type $A, and then I'm going to type .count. And what that will do is tell me how many objects are associated with that variable. So I should have 22. And when I press enter, I see that we have 22. So that's just something that I wanted to show you. Now let's move on to the primary topic of discussion and begin creating some user accounts through PowerShell. Now the command that we use to create user accounts in PowerShell is new-ad user. I'll go ahead and type that now. Now there are a few parameters that we would generally use with this commandlet. The first one being name. We have to provide a username. And the way that we do that is by typing -name, and then in quotation marks, the name of the user account that we want to create. I'm going to type quotation marks, user23, quotation mark, and then typically you'll want a user principal name. So I'll type -user principal name, and then you would enter the user principal name, and that's generally the user's email address. So in this case, it's going to be user23 at, and then my domain name, which is pshell.com. So then I'll go ahead and press enter. And the user account has been created. If I repeat my previous command, you can see that the last user account on the list is user23. So we have indeed created a user account using PowerShell. Now, even though that user account exists, we're not quite done because the user account has to be enabled before it can be used. So how do you enable a user account? Well, I'm getting ahead of myself a little bit here. So before I show you how to enable the user account, let's take a look at how to confirm whether or not that user account is enabled. So what I'm going to do is repeat my previous command, and rather than just having select object name, I'm going to add enabled. And I press enter, and you can see that all of those user accounts are enabled except the last one, which is the one that I just created, user23. And we have a value of false, indicating that that account is not enabled. Now, what if I wanted to look at just this account? I could easily do that in roughly the same way. I'll type get-ad-user, user23, -properties, enabled, and then pipe symbol, select object, name, enabled. And you can see that user23 is not enabled. So how do we enable that user? Well, the way that you would do that is through the enable-ad account commandlet. Here's what that commandlet looks like. Enable-ad-account -identity and then the username, user23 in this case. So this is the command, and this is a perfectly valid command, assuming that I haven't made any typos. But when I press enter, I'm going to get an error message. Let's take a look. And you can see the error message. So why did I get an error? Well, if you look at the error message, it indicates that the password does not meet the length, complexity, or history requirements of the domain. Now, I'm working in a lab environment. I'm using a domain name called pshell.com. I don't even own that domain name. That's just something I'm using for a PowerShell course. So the reason why I say that is to say that my security is lax, to say the least. I'm just using default values for my security. But even so, Windows by default imposes some length, complexity, and history requirements on your Windows passwords at the Active Directory domain level. And so we have to adhere to those requirements. And so when we enable a user account through PowerShell, we're not able to enable that account unless that password meets those requirements. So the account that we just created, you might have noticed it doesn't even have a password associated with it. As you might recall, when we created the user account, we never specified a password. So how do we associate a password with this account? Well, it's relatively easy to do. Let me show you the command that we use to do that. We type set-ad account password space -identity and then the username. I'll go ahead and press enter. And now I'm prompted to enter the current password for the account. Now this account doesn't have a password, so I just press enter. And now I'm prompted to enter the new password for the account. I'll go ahead and do that now. I'm asked to repeat the password, and I'm only going from memory here, so I could be wrong, but I believe that some of the earlier versions of Windows Server didn't give you an opportunity to retype the password, so you had to be really careful with typing the password to make sure that you got it correct. But I'll go ahead and repeat the password. And so the password has been set for that user account. Now we should be able to enable the user account. So let's go ahead and do that. I'll type enable -80 account -identity user 23. And I'll press enter, and we didn't get any kind of error messages, so presumably this account is now enabled. So let's go ahead and double check just to make sure that we did enable it. I'll go ahead and repeat the command that we typed earlier, which is get-80 user 23 properties enabled, type symbol, select object, name, comma, enabled. I'll press enter, and it looks like I forgot a dash on properties. So let me go ahead and retype that command, and I'll put a dash in here in front of properties. And so now I see that user 23 is indeed enabled. So we've created a user account using PowerShell, we've associated a password with that account, and we've enabled the account. So this account is ready to use. But you have to admit that even though we were able to do all of that through PowerShell, that was a lot of work. And think about all of the steps that we had to go through. First, we created the account, then we had to associate a password with the account, then enable the account, and then verify that the account was enabled. That's at least 4 high-level steps involved in just creating one user account. It, in all honesty, probably would have been easier to use the GUI. So why use PowerShell? Well, there's a couple of reasons. One, you can do this in a simpler way than what I just showed you, and we'll get to that in a moment. The other is that PowerShell also gives you the ability to create user accounts in bulk. So if you've got a lot of user accounts to create, it's going to be a lot easier to use PowerShell because you can bulk create those accounts straight from a CSV file. And I'll show you how to do that in a little bit as well. So having said that, let's take a look at what we could have done to simplify this process. And to do that, we're going to create another new user account. So I'm going to type new-80 user. Next, I'm going to type -name, the user account, and I'm going to create user 24. And we want to go ahead and associate a password with this user account. So I'm going to type -account password, and then parentheses, read host, and then space dash as secure string. And then I'm going to type another space. And even though we've used spaces indiscriminately throughout this course, the space that I just typed is extremely important. This command won't work if you don't type this space. So then I'll type quotation mark, and then account password, quotation mark, and then parentheses. I'll press enter, and now I'm prompted to enter an account password. I'll go ahead and type an account password. And you'll notice that because I'm entering this as a secure string, due to the as secure string parameter that was associated with the read host cmdlet, PowerShell is automatically masking the password as I'm typing it. So I'll press enter, and the account is created, and it's got a password associated with it, meaning that now all I have to do is enable the account. So I'll say enable -80 account -identity user 24. So the account should be enabled. Let's go ahead and check that. And I'm just using exactly the same command that I used a little bit earlier, but with a different username. and I'll press enter, and we can see that the new user account has been enabled. Now, we can simplify things even just a little bit more by doing it all in one step. So let me show you how that works. I'm going to type new-AD-user -name, the user account name. This one will be user25, and then -account password, and then open parentheses, read host, -as secure string, and that all-important space that I just typed, and then quotation mark, account password, quotation mark, close parentheses, and then -pass-through. And note the spelling on pass-through is P-A-S-S-T-H-R-U, not P-A-S-S-T-H-R-O-U-G-H. And then the pipe symbol, and then enable -AD account. Now, hopefully I haven't made any typos, but assuming that I typed all of this correctly, we should be able to create and enable user25 all in one step. I'll press enter. I'm prompted for a password, and the account's been created. Let's see if it's enabled. And I'm just going to use the up arrow as a shortcut and replace user24 with user25. And user25 exists and it is enabled. So we just created and enabled a user account in a single step. Now, as I mentioned earlier in this video, PowerShell also gives you the ability to bulk create user accounts. So let's take a look at how that works. Typically, when you're going to bulk create user accounts, the way that you would do that is by creating a CSV file containing a list of the user accounts that you want to create, and then you would use the import-csv file to import that file and then create a new Active Directory user account based on the items within the file. And there are countless variations on this technique. So certainly the way that I'm about to do it isn't the only method. But let's take a look at how this works. So to get started, I'm going to open up File Explorer, and I'll go to my scripts folder, and I've created a file called users.csv. I'll open this in Notepad. And here you can see what the file looks like. So the top row contains column headers. We have name, given name, surname, SAM account name, and user principal name. And then the subsequent rows contain the information for the user accounts. Now in this case, I'm only using a username. You'll notice that each username is followed by a series of commas. And if I were supplying a given name, a surname, a SAM account name, or a user principal name, then those pieces of information would be inserted between the commas for each user account. But in the interest of keeping things simple, I just supplied the username and that was it. And if you want to create user accounts from a CSV file, you can always copy this file as is and then just substitute your own information for the user accounts that you want to create. I'll go ahead and close this out. And I'll switch back to PowerShell. And let me go ahead and clear the screen just to get rid of some of the clutter. So the command that we're going to use to bulk create user accounts is going to be import-csv. And then I need to provide the path and file name for the CSV file that we want to use. So that's c:/scripts/users.csv. So that commandlet imports the CSV file. Next, I'm going to use a pipe symbol followed by new-AD-user. So what we're doing is we're importing the contents of a CSV file and then we're piping those contents into the new-AD-user commandlet. So type space and then -pass-through. Again, note the spelling of pass-through, and then pipe symbol, and then we have to provide a password. So I'll type set-AD account password. And then -reset, -new password. So we're essentially treating this as a password reset, And I need to open parentheses and convert to secure string. And then dash as plain text. And you have to be a little bit careful with this one because the password will be visible. And I'm just going to set the password to the old @SSW0RD. Of course, you want to use a more secure password than this in a production environment. I'll pin dash force, close parentheses, dash pass through, and then pipe symbol and enable dash AD account. And hopefully I haven't made any mistakes in my typing. I'll press enter, and we didn't get any error messages. So let's take a look and see if those new accounts have been created. I'll type get dash AD user dash filter bracket name like quotation mark asterisk user asterisk quotation mark bracket dash properties name comma enabled type symbol select object name comma enabled. I'll press enter, and here we can see all of our new user accounts that we just created by importing them from a CSV file, and we can verify that those accounts exist and that they are enabled. So that's how you create user accounts using PowerShell. Hello and welcome back. So far in this lesson, we've done quite a bit. In the first video in this lesson, I showed you how to use the get-AD-user commandlet to access attributes associated with user accounts. And then in the second video, I showed you how to use PowerShell to create brand new user accounts from the command line. Now, I want to use this opportunity to show you how to populate missing attributes and how to modify existing attributes. So just as a refresher before we get going, I want to open up Server Manager. And then I'm going to go to Tools, and then Active Directory Users and Computers. So here we are in the Active Directory Users and Computers console, and you can see that the users container is selected. And down here we have all of the user accounts that we have created throughout this course. Some of these I had created in advance, some of them we created from the command line using PowerShell in the last video. So let's go ahead and open one of these up. I'm going to right-click on User 1 and choose the Properties command. And this is going to open up the User 1 Properties dialog box. And you can see that there are certain attributes that are populated for User 1. For example, we can see that User 1 works in the Miami office. Here we have User 1's telephone number. And if I switch over to the Organization tab, you can see User 1's job title. You can see the department that User 1 works in. You can even see User 1's direct reports down here. So we have all of these attributes that have been populated for User 1. Now, let me go ahead and cancel out of this, and let's take a look at User 30. This was the last user account that I created in the last video. So I'm going to right-click on User 30 and go to Properties, and let's take a look at User 30's properties. The General tab is pretty well empty. We don't have a first name, a last name, a display name. We don't have an office. If I go to the Organization tab, this is also empty. No job title, no department, no company, no manager, nothing. So why is that? Well, if you think back to the previous video, we created user accounts, but we did so in a very basic way. Really, the only thing that was associated with those user accounts that we created in the last video was a password. We created the user account, we assigned a password to the user account, and we enabled the user account. And that was really the extent of what we did. I didn't bother associating attributes with the user account in that video because I didn't want things to become overcomplicated. But the problem with that is that now we're left with a whole bunch of new user accounts that have 0 attributes associated with them. And that's what we're going to fix in this video. We're going to go ahead and assign some attributes to those user accounts. So while I'm at it, not only are we going to assign attributes to user accounts, I'm also going to show you how to modify existing attributes. And just so that you know, you use the same technique for both. So let me go ahead and close out of this. And here we are in PowerShell. So the first thing that I want to do is take a look at one of our new user accounts. And let's just make sure that this particular user doesn't have an Office attribute set. I don't think it does, but let's check to be sure. So I'm going to type get-80user. And I'll go with user 23. And then I'll type dash properties, office, and then pipe symbol, and select dash object, name, comma, office. And I'll press enter. And as suspected, user 23 does not have an office associated with it. So let's go ahead and assign an office attribute to user 23. And the way that we do that is by using a PowerShell commandlet called set-80user. And this is a really simple commandlet to use. The way that this works is we type set-80user. Then we have to provide the username, which in this case is user23. Then we have to provide the attribute that we want to assign. In this case, we're trying to assign an office to the user, so we're going to be working with the office attribute. So I'll type dash office. Then the last thing that we have to do is, within quotation marks, enter the value that we want to assign to the attribute. So the value is going to be the physical location, the attribute is office. So I'll assign Las Vegas as the value. And I'll press enter, and we don't get any visible output. That's usually a good sign in PowerShell. So let's just double check and make sure that this value was indeed assigned to user 23. And to do that, I'm just going to repeat the command that I typed earlier. Get-80user, user23, dash properties office, select object, name, comma, office. And when I do that, you can now see that the office has been set to Las Vegas. Easy enough. Now, as we all know, in the real world, things are rarely static. Users move around all the time. Users get promoted, users move. We have all kinds of changes that happen in the real world. So let's pretend for a moment that user 23 got a job transfer and they moved from Las Vegas to Miami. So they're now working in the Miami office. So we need to change the office attribute from Las Vegas to Miami. How do we do that? Well, conveniently enough, we can use the exact same command that we just used. We don't even have to change anything other than the office name. So we type set-80user, user23-office, and then all we have to do is change Las Vegas to Miami. And I'll press enter. Again, no visible output, which is usually a good thing. So let's check and make sure that the change has taken effect. So I'll use get-80user, user23, properties office, select object name, comma, office. And now we can see that user 23 is a part of the Miami office. So that's how you assign an attribute, and that's how you modify an existing attribute. So what else can we do? Well, what if we wanted to find out which users don't have an office assigned? To do that, the command that we're going to use is just a little bit more complicated than what you've seen, but not by much. I'm going to resort to using the get-80user commandlet. I'll type get-80user, and I'm going to set up a filter. So I'll type bracket and then name dash like, and I'll use the exact same filter that we used in the previous video. Quotation mark, asterisk, user, asterisk, quotation mark. So we're searching for any user account that has user as a part of the username. So that's going to be user 1, 2, 3, 4, 5, all the way up to 30. But we're going to turn this into a compound filter because we don't just want a list of all of the users. We want a list of the users who don't have an office assigned. So I'm going to type -and as a way of indicating to PowerShell that we're creating a compound filter, and we don't want results returned unless a user account fits two different criteria. It has to fit both. The first of those criteria is the user's name is like user, and then the second criteria is office dash not like, quotation marks, asterisk, quotation marks. And then I'm going to use the pipe symbol and select dash object name, comma, office. Press enter. And so here you see that users 24 through 30 do not have an office assigned. So what can we do about assigning an office to those users? Well, actually, before I answer that question, let me take a step back for a moment. And I want to talk just a little bit more about the command that I just used. Let me retype that. Now, I mentioned that I was using a compound filter in this command. And that compound filter uses the AND operator to indicate to PowerShell that there are two conditions that have to be true in order for a result to be returned. The first of those conditions is that the username has to contain the word user. The second of those conditions is that the office has to be empty. And to do that, I said, and office not like asterisk. So you might be wondering why I used not like asterisk as opposed to something else. Well, as much as I wish I had a better answer for you, that's the only way that works. That's why I did it that way. Because if I were to say equals as opposed to not like, and I just change this to equals nothing, and I press enter, I get an error message. Similarly, if I set equals to null, and I press enter, I get an error message like that as well. So to get the results that we want, we kind of have to do not like asterisk. So in PowerShell, remember, asterisk means everything, all results. So if we're saying not like everything, we're essentially telling PowerShell a field where nothing exists. And there's our results. So let's go ahead and assign an office to these users. For the sake of simplicity, let's pretend that all of these users work in the Miami office. The way that we assign an office to those users is really simple. I'm going to begin by retyping exactly the same command that we just used. And then what I'm going to do is append a pipe symbol. And then I'm going to type set-80user -office and Miami. And I'll press enter. And so as you can see, we got an error message. So let's take a look at what went wrong. And I think that the problem here is that I forgot to take out select object. So let's go ahead and get rid of that. And let's try this again. So I didn't get any visible output that time. So it seems like the command worked. Let's go ahead and verify this. I'm going to repeat the command that I used earlier. Get-80user, filter name like user and office -not like asterisk, select object name, comma, office, and I get no results. So that theoretically tells us that there aren't any user accounts that have user within the account name and that don't have a value for office. But let's go ahead and just make sure. So I'm going to type get-80user -filter name -like quotes asterisk user asterisk quotes bracket and then dash properties office and then pipe symbol select object name, comma, office. And I'll press enter. And here we see all of the users and the office that they work in. And you can see that all of those user accounts have been assigned to the Miami office. So what we just did worked. Now, if you think back to the previous video, one of the things that I did in that video was to bulk create user accounts. And in the spirit of that video, I want to show you a couple of different techniques that you can use to assign attributes to user accounts in bulk. I'm going to show you two different methods. So what I want to do is open up File Explorer, and I'll go to my scripts folder. And I'm going to open up 5-3.ps1. And here's what the script looks like. So what the script does is it will assign all of the users within a certain range to a specific office. Right now this is set to Miami, but we just set all of these users to use the Miami office. So let's change Miami to Las Vegas. And I'll go ahead and save this. And let's take a look at how this works. We're setting up a for loop. So in the very first line, we have for $A equals 25. So 25 is going to represent our first user. This is going to be user 25. Then we set a condition, $A is less than or equal to, that's LE, less than or equal to, and then 30. So we're checking to see if our counter is less than or equal to 30. Remember, user 30 is our highest numbered user. And then $A plus plus. So this is going to increment the variable $A each time that the loop is run. So the loop is going to start at user 25, then it's going to go to 26, 27, 28, 29, and end with 30. And within the loop body, we have a couple of different things. The first thing we're doing is setting up a variable called $user, and we're setting that equal to user $A. So this is going to set the variable user to user 25 or user 26 or whatever the current user happens to be. Next, we have a write host command. We don't really need this command. I just included it so that you could see what was going on, but it's going to display the name of the current user. You'll notice that we're outputting the $user variable. So we should see on screen user 25, user 26, user 27, and so on as the loop progresses. Then we've got set-ADUser, that's the command used to populate or modify an attribute, $user, that's the current username, -office, and then Las Vegas. So I'll go ahead and save this. And I haven't actually tested this script yet, so let's hope that it runs. So /5-3.ps1. And so remember, I've got that write host command in the script that outputs the name of the current user. That's why you're seeing user 25, user 26, user 27, user 28, user 29, and user 30. And we're not getting any error messages, so I'm assuming that the script worked. Let's go ahead and check this. Now, if you look higher up on the screen, you can see that user 25 through 30 are currently assigned to the Miami office. So when I repeat that command, we should see that those users are now in Las Vegas. And indeed they are. You can see that right here. So that's one script that I wanted to show you. There's one other. So let me go ahead and close out my current script and switch to File Explorer. Now, in preparation for this video, I created a CSV file. And I called that usermod.csv. And if I open this up, we just have a header row that says users, and then I list user 25, user 26, 27, 28, 29, and 30. And there are no commas in this file because I've just got one value per line, so we don't need commas to separate values. So let me go ahead and close my CSV file, and let me open up the script that I created. Now, the reason why I created a second script is because my first script worked, but it was kind of impractical for the real world. Because in most organizations, you're not going to have users named user 1, user 2, user 3. So using a counter to progress through usernames really isn't practical in the real world. Typically, you're going to have users with real names. So this script that I'm about to show you will read in a list of usernames from a CSV file and then process those users accordingly. Let's take a look at how this works. So let me go ahead and open up this script file in Notepad. So here's what the script looks like. We're beginning with the import-csv statement. And I'm importing c:/script/usermod.csv. That's the CSV file that I just showed you. Then we have the pipe symbol. And then we're setting up a loop. And I've got for each object. So this is going to take a look at each line of the CSV file. And then we have a bracket. So anything between brackets, that bracket and this bracket, is going to be processed for each line in the CSV file. So what are we doing? Set-ADUser, and then $_users. And this is the position where you would normally type the username. Instead of the username, we're typing $_users. Now, where did this come from? Well, let me go ahead and switch back to File Explorer and open up my usermod.csv file. You'll recall that I mentioned that this particular file begins with a column header, this line right here. And that column header just happens to be called users. So that's why in our main script, we're referencing $__users. The users portion of $__users has to match the column header in our CSV file. So that's where the word users came from. So let's move on. Then we have -department and marketing. So what we're doing is we're going through our CSV file, and for every user who's listed in that CSV file, we're setting the department to marketing. So let me go ahead and close this out. And again, I haven't tested this file ahead of time because I didn't want to populate a bunch of attributes and then have to go in and undo those attributes in order to record the video. So hopefully this will all work the way that it's supposed to. I'll type /5-3b.ps1. And we didn't get any errors or any visible output, so presumably the script worked. So let's go ahead and take a look. I'm just going to use the same command that we used earlier, but I'm going to modify this a little bit. I'm going to look at office and department. And then I'll also add department to my select object command. I'll press enter, and we can see that PowerShell now indicates that user 25 through 30 work in the marketing department in Las Vegas. So that's how you can bulk modify attributes for Active Directory user accounts using PowerShell. Hello and welcome back. Throughout this lesson, I've been talking all about the ways that you can interact with the Active Directory using PowerShell. And I've been focusing primarily on user accounts. But as I'm sure you know, there's a lot more to the Active Directory than just user accounts. I mean, think about all the other types of objects that exist. We have computer accounts, we have group policies, we have groups. So I thought that it might be nice to round out this lesson by taking a look at least one other type of Active Directory object. So let's talk about groups. Now, the way that you access an Active Directory group through PowerShell is by using a commandlet called get-adgroup. Let's take a look at this commandlet. And if I press enter, I get a prompt asking me for a value. So I'm going to press Control-C to break out of this. And what I'm going to do now is I'm going to build on the get-adgroup command. So I'm going to type get-adgroup and then -filter *properties name. And hopefully by now this is starting to look very familiar because the syntax is nearly identical to the get-80 user commandlet that I talked about in the last several videos. So then I'm going to append a pipe symbol, and I'm going to type select object name. And when I do that, I get a list of all of the Active Directory groups that exist within my Active Directory domain. And I'll scroll up just a little bit so you can see all these groups. And these are built-in groups, by the way. I haven't actually created any groups in this environment. So everything that you see right here exists by default. So what if we wanted to see a group's membership? Well, we can do that through PowerShell as well. And the way that we do that is by typing get-80 group member. And of course, we have to specify the name of the group whose membership we want to examine. And the way that we do that is by adding the identity parameter. So I'll type -identity. And then we need the group name. So I'm going to just look at domain admins. And I'll press enter. And we can see that there is only one user who's a member of the domain admins group, and that is the built-in administrator account. But that's how you take a look at a group's membership. So even though I looked at domain admins, this technique works for any group that you have within the entire Active Directory environment. Now, what if we wanted to reverse things a little bit? I mean, we've seen that the administrator is a member of the domain admins group, but what if we wanted to know what other groups the administrator is a member of? Well, we can do that too. The way that we do that is by typing get-80 user, and then we have to type the username. And once again, I'm looking at the built-in administrator account, so I'm going to type administrator. Next, I'm going to enter -properties. And the property that I'm interested in is called member of. And then I'm going to append a pipe symbol and then select dash object. And we're going to look at name, comma, member of. And I'll press enter. And so there's our output. And the output's a little bit messy, so what I would typically recommend doing is repeating this command and then just appending a pipe symbol and typing format list. So here are the groups that the administrator is a member of. So we can do that through PowerShell. So now that I've shown you how to look at groups and memberships and things like that, I want to change my focus to creating a group. And the way that we create a group in PowerShell is by using a commandlet called new-ad group. Let me go ahead and clear the screen. And if you think back to the previous videos, you'll recall that I had a lot of fake users who were in the Miami office. So what if we wanted to group all of those users into a common group? We could create a group called Miami to store all of the users in the Miami office. And the way that we do that is by typing new-ad group. And then we have to assign a name to the group, so I'll type -name, and then in quotation marks, Miami. And then there are a couple of additional parameters that we have to supply. We have to tell PowerShell what type of group we're creating. So I'm going to type -group category. And it makes a lot more sense to make this a security group rather than a distribution group. So I'm going to enter security as the group category. And then we also have to assign a scope to the group. And we do that by appending the group scope parameter. And I'm going to make this a global group, so I'll enter global as the group scope. And I'll press enter. And there's no visible output, so presumably the group has been created. The way that we can check is by going back to the get-ad group commandlet and entering the group name, which is Miami. I'll press enter, and we can see the group. And as you can see, there are several different pieces of information that PowerShell supplies. We see the group name, the object class, the object GUI, the SAM account name, the SID. But the main things that you should pay attention to here are the group scope, which is global, and that matches what we put into PowerShell. We set our group scope right here. And then also the group category. Within our commandlet, we set the group category to security so that we could create a security group. And then right here, you can see group category security. And you can also see the distinguished name for the group in case you're curious. So we've created a group through PowerShell. Now the next step in the process would be to begin adding some users to that group. And remember, we created this group as a way of grouping together all of the users who are working in the Miami office. So how do we get those users into that group? Well, from a PowerShell perspective, there's a couple of different ways that we can do this. So I'm going to show you a couple of different techniques. The first technique is to manually add a member to the group. So I'm going to type get-ad group Miami. And that's the exact same command that I just typed. This is what retrieves our group. And then I'm going to append a pipe symbol. Next, I'm going to type add-ad group member. And then I'm going to append -members. And let's add user 20 to the group. And I'll press enter. And once again, there's no visible output. And in PowerShell, that's usually a good thing. If everything goes right, a lot of times you don't have any visible output. If something goes wrong, typically you'll get an error message. So anytime that you press enter after entering a command and nothing appears to happen, that's typically a sign that everything worked. But even so, we should probably confirm this just to make sure that user 20 really was added to our Miami group. So how do we do that? Well, we do that by using the get-ad group commandlet. And once again, we'll enter the group name, Miami. And then I'm going to type -properties, members. And then I'm going to append the pipe symbol, followed by select object, members. And we can see that user 20 is a member of the group. So our command that we used to add user 20 to the Miami group worked. Now, we could easily use this technique to add anybody that we want to the Miami group. That would totally work. It's a perfectly valid option. But having said that, it would be a lot of work. Because if you think about it, we've got 30 users in our group, and really that would represent a small company, but still 30 users. Can you imagine having to go through a list of 30 users, figure out which ones are in the Miami office, and then manually add each one of those Miami users to that group using the technique that I just showed you? Sure, it could be done. It could absolutely be done, but it would take some time. It'd be really tedious to do. So there is a better way within PowerShell. We can bulk add members to a group based on existing attributes. So let's take a look at how to do that. What I'm going to do is I'm going to type get-80users, and then I'm going to create a filter. So I'll type -filter, and then I'll type bracket office -eq for equals Miami. And if I press enter, I get an error message, and the reason is because I misspelled my get-80user command. I typed get80users, not get80user. So let me redo that. I'll just delete the S off of the end of get80user, and I'll press enter. And so now I get a list of all of the users in the Miami office, and I can use this list to populate the group. So how do we do that? Well, what I'm going to do is repeat the exact same command that I just typed, but what I'm going to do is I'm going to assign the command to a variable. So I'll go to the beginning of the command and I'll type $A equals, and you can use any variable name you want. I just use $A. I'll press enter. And so now I have a variable called $A that's set to the list of users in my Miami office. Well, what we can do is type get-80group, and I'm going to set that equal to Miami. And then I'll add the pipe symbol, and then add -80 group member, and then -members. And then rather than supplying a list of members, what I'm going to do is use my $A variable that I created in the previous step. I'll type $A and press enter. And again, no visible output, so usually that's a good thing. Okay, so let's verify that those particular users were added to our Miami group. And the way that I do that is by typing get-80 group, and then I'm going to type the group name, which is Miami, and then -properties, members, and then I'm going to add a pipe symbol and select -object, members. I'll go ahead and press enter, and I can see the group members. And if I wanted to make this a little bit less messy, I could always format this differently by adding a pipe symbol and then typing format-list. And so now you see the member list in a format that's just a little bit easier to read. So that's how we verify that the users were added to our Miami group. Now there's one last thing that I want to show you before I end the video. I want to show you how to remove a group. So within this video, I've created a group called Miami, and we can verify that group's existence by typing get-80 group Miami. And so there you see my group. Now, what if I wanted to delete this group? Well, to delete the group, I would type remove-80 group, and then the group name, Miami. I'll press enter. I see a prompt asking me, are you sure you want to perform this action? I'll type Y for yes. And so now presumably my group has been removed. And I can verify that by repeating the get-80 group Miami command. And when I do that, I get a message saying cannot find an object with the identity Miami. So the group has been deleted. So that's just a sampling of some of the things that you can do with Active Directory groups through PowerShell. As you saw in Lesson 6, PowerShell is really useful for server management, but it becomes much more useful when it's used to bulk manage multiple servers. Of course, doing so requires you to be able to run commands on remote systems, and that's what Lesson 7 is all about. The topics in this lesson include an introduction to PowerShell Remoting, establishing a remote session, running a cmdlet on a remote system, and compiling data from remote servers. Hello and welcome back. The videos in this lesson cover a really important topic, PowerShell remoting. Now, what is PowerShell remoting? PowerShell remoting refers to being able to use PowerShell to establish a remote session with other computers on your network. So in other words, you can be sitting at your own local computer and interact with another computer on your network just as if it were local. The PowerShell command prompt is actually redirected so that you're interacting with another computer on your network. It's a super convenient technique because if you really think about it, PowerShell serves two purposes. One, it acts as a programming language, and you'll be seeing a lot of that in the next lesson. But two, PowerShell acts as a management tool for Windows. So by being able to establish a remote session with another computer on your network, you can manage that computer through PowerShell without actually having to be at that computer's console. But I'm getting a little bit ahead of myself because I'm not actually going to show you how to establish a remote session until the next video. My purpose in this video is to talk about why PowerShell remoting is important. Now, I've already laid out the reasons. It's convenient to be able to sit at your own computer and interact with another server on your network as if you were sitting at that server console. That's a given. But why establish a remote session? Because after all, you've already seen in some of the earlier videos that it is possible to interact with a remote system without having to establish a remote session. We've done it quite a few times throughout this course already. Think about the get-vm command. That's the PowerShell commandlet that retrieves a list of virtual machines that are running on Hyper-V. I've used the get-vm commandlet quite a few times, and I used a parameter called computer name to tell PowerShell that I wanted to get the list of virtual machines off of the Hyper-V server on my network rather than looking for those virtual machines locally. So that underscores the idea that it is possible to interact with a remote system without having to establish a remote session. So why establish a remote session? Well, one of the reasons why you might want to establish a remote session is just for convenience. Because when you establish a remote session, you actually redirect the PowerShell prompt to a remote system. So every command that you type is being directed against that remote system, and you can treat it as though it were local. So there's the convenience factor. You don't have to specify -computer name with every command that you type. The other reason, and the more important one, is because the computer name parameter doesn't work with every PowerShell commandlet. There are a lot of commandlets that don't support computer name. And plus, if you want to do some of the more complex things, you really need to be able to establish a remote session in order to get those tasks done. But I want to go back to the point that I made just a second ago that not every PowerShell commandlet supports the -computer name parameter. A lot of them do. I've already shown you get-vm in some of the earlier videos. The get-service commandlet also supports the use of a computer name. For example, if I were to type get-service, and then I'll specify a service name, maybe VSS, and then -computer name, Hyper-V, which is the name of the Hyper-V server on my network, I'm actually seeing the VSS service on that Hyper-V server. Now, just to show you that I truly am looking at a remote system, let's look at the local copy of the VSS service. So I will remove computer name, and you can see the local VSS service. I'm going to go ahead and start the VSS service locally. And I'll do that by typing start -service VSS. And so now if I do the get service VSS command, I should see that that's running. Now, if I repeat the same command that I typed a moment ago, get service VSS-computer name Hyper-V, I can see that the VSS service is stopped on my Hyper-V server, but it's running on my local machine. So I truly am interacting with a remote machine, and I haven't established a remote session to do that. But as I said a moment ago, not every PowerShell commandlet supports the use of the computer name parameter. I'll show you a really simple example of that. Let's suppose for a moment that I want to start the VSS service on the Hyper-V server. I'll type start -service VSS-computer name Hyper-V. And I get an error because the start service commandlet doesn't support the computer name parameter. As a matter of fact, if I type get-help start-service, I see the full command syntax. And if you look at the syntax, you can see that the computer name parameter is not included in any of this. Whereas if I were to type get help, get dash service, you can see the computer name parameter right here. So the get service commandlet supports a computer name parameter, but the start service commandlet doesn't. Now, in all fairness, yes, you can pipe these together. So if, for example, I were to type get dash service VSS dash computer name Hyper-V, and then the pipe symbol, and then start dash service, and then get service VSS computer name Hyper-V, now that service is running on the Hyper-V server. So a lot of times there is a workaround that you can use, but that still doesn't change the fact that not every PowerShell commandlet supports the use of the computer name parameter. So that's one of the big reasons why you might want to establish a remote session. Now, incidentally, you'll notice that I'm starting and stopping the VSS service a lot throughout this video. And the reason why I picked the VSS service, if I haven't mentioned it already, is because that service is associated with creating backups. And we're not creating backups right now, so we can start and stop that service without causing any problems. You don't want to be picking services at random and starting and stopping them because you can cause problems with Windows if you do that. At any rate, I just wanted to demonstrate the fact that not every PowerShell commandlet supports the use of the computer name parameter, so sometimes it can be beneficial to establish a remote session to work around that limitation. So with that said, I'll see you in the next video. Hello and welcome back. In the last video, I explained why it's so important to be able to establish a remote PowerShell session with the servers on your network. Because while some of the PowerShell commandlets do have a computer name parameter that you can use to direct that commandlet against a remote system, typically you're going to need to establish a remote session if you want to do anything more complex than that. So remote sessions are undoubtedly important. But the real question is, how do you actually establish a remote session? Well, that's what we're going to be talking about in this video. Now, before you can establish a remote session with a computer on your network, you're going to have to enable PowerShell Remoting, or PS Remoting, as it's sometimes called. And that's something that has to be done on the remote system. So you'll actually have to pull up that server's console and enable PowerShell Remoting on that system before you'll be able to establish a remote connection to that system. Right now, I'm just connected to my own local machine, not to the remote machines. And as I said, it's the remote machine where you'll want to enable PS Remoting. But I'm going to go ahead and show you the command on this system just so that you can see what it looks like. And incidentally, PowerShell Remoting is already enabled on this system, but let's go ahead and do it anyway. So the command that you'll use is enable -PS Remoting --force. And if I press enter, PowerShell will take just a second, and then it'll take me back to the command prompt. And we won't get any visible output, even though PowerShell Remoting is already enabled on this system. So at this point, PowerShell Remoting is enabled. I'll go ahead and clear the screen. And I want to talk for just a moment about a commandlet that I've used extensively throughout this course, get-service. As you're well aware, if I type get-service, I get a list of the services that are running on this particular machine. And if I want to look at a specific service, then I would type get-service followed by the service name. So if I wanted to look at the volume shadow copy service, for example, I would type VSS. And then PowerShell shows me the volume shadow copy service. Now, the reason why I pointed that out is just because when I connect to a remote system, I'm going to use the get-service commandlet to prove that I really am connected to a remote system. And to do that, what I want to do is I want to repeat the get-service commandlet right now. And the service that I want to look at is called VM Compute. Now, if you're not familiar with the VM Compute service, it's a system service that's associated with Microsoft Hyper-V. Hyper-V being Microsoft's virtualization platform. Now, if I press enter, I'll get an error message. And the reason why I get that error message is because Hyper-V is not installed on this particular server. So what I want to do is I want to establish a remote session to my Hyper-V server and repeat this get-service VM compute command and PowerShell should be able to find that service there. So let's go ahead and get started. The first thing that we need to do is provide PowerShell with a set of credentials that it can use. And I do that by typing $cred. Cred is just a variable name. You can actually use any variable name you want. And I'm going to set that equal to get credential. And now I see the prompt for a set of credentials. So I'll go ahead and enter my username and password. And then if I take a look at the cred variable, you can see that it does indeed contain a set of authentication credentials. So we're all set there. So the next thing that we have to do is to use the enter ps session commandlet to establish a session with the remote server. So I'll go ahead and do that now. I'll type enter -ps session -computer name Hyper-V, which is the name of my Hyper-V server, and then -credential $cred. So we're telling PowerShell that we want to establish a remote session with a computer named Hyper-V, and we want to use the credentials that are stored in the $cred variable to authenticate to that remote system. So I'll go ahead and press enter. And when I do that, you'll notice that the PowerShell prompt has changed. Whereas before, we just had PS space and then $\\sign. Now we have in brackets the word Hyper-V. And so this is an indication that we're connected to a remote system. We're connected to a server that has the name Hyper-V. And you'll notice that even my path has changed. Right now I'm looking at c:/user/administrators.pshell/documents, whereas before I was in the root directory. Right here you can see c:/. So let me just go ahead and go down to the root just to kind of clear some of the clutter. And what I want to do is I want to repeat that get service vm compute command that you saw earlier. So there's the command. I'll press enter. And now PowerShell finds that service because we're not looking at the local system services. We're actually connected to a remote system and we're looking at the services that are running on that remote system. So the point being that now that we're in a remote session, we can direct any command that we want toward this remote system as if we were working on the local system. Now, one last thing that I want to quickly mention about this is that when you're done, it's important to use the exit ps session commandlet to go back to your local instance of PowerShell and to close that remote session. And the reason for this is that you can establish multiple remote connections to a remote system, but if you do too many, eventually those connections will start being refused. So as a best practice, you should always exit out of a PowerShell session when you're done with it. And the way that you do that is through the exit-ps session commandlet. I'll go ahead and type that now. And I'll press enter, and you'll see the PowerShell prompt change immediately. And we no longer have Hyper-V in brackets, indicating that we're now looking at the local system, not a remote system. And if I try that get service vm compute commandlet again, now I get the error because I'm back on my local system and Hyper-V isn't installed, so that service doesn't exist on this particular computer. So that's how you establish a remote session to another computer on your network and how you terminate that session or exit out of that session when you're done. In the last video in this lesson, I demonstrated the fact that when you establish a remote session with a computer on your network, the PowerShell prompt actually changes so that all of the commands that you type get redirected to that remote system. That's great. That definitely has its use case and it can be super handy. But sometimes you might not want to redirect the entire PowerShell prompt. You might want to run one or more commands against a remote system, but without fully redirecting everything. And there is a way to do that. So that's what this video is all about. I want to show you how you can run one or more commands on a remote system, but without having to completely redirect the PowerShell prompt the way that I did in the last video. So let's go ahead and get started. The first thing that I need to do is to set up a variable containing the credentials that are going to be used to authenticate into a remote system. So I'm going to create a variable called $cred, and I'm going to set that equal to getCredential. I'll enter my username and password. And I'll double check the contents of the cred variable. So I'll type $cred. And so my credentials are being stored. Let me go ahead and clear the screen. And then the next thing that I want to do is to set up another variable. I'm going to call this one $session. And you can call this variable anything that you want, obviously, but using $session seems to be a standard. This is what a lot of people use. So I'm going to create a variable called $session. And I'm going to set that equal to new PS session. And so then I'm going to type -computer name. And then the name of the server that I want to connect to. I'll use my Hyper-V server again, so I'll type Hyper-V because that's the computer name. And then -credential, $cred, and I'll press enter. And so now I've created a variable called $session, and I've set that equal to a new PowerShell session on my Hyper-V server using the credentials contained in the $cred variable. So that's where we're at right now. Now, take a look at the PowerShell prompt. You'll notice that the prompt still points to my local system. I'm looking at my C drive. So I haven't redirected the entire console the way that I did in the last video. So how can we run commands against this remote system if we haven't redirected the console? Well, the way that we do that is we use the invoke command commandlet. Let me show you how this works. I'll type invoke -command and then -session. And then I need my session variable, so $session. Then I need to tell PowerShell what command or commands it is that I want to run against the remote system. So I'll type -script block, and then an open bracket, and then anything that I include inside of this bracket is what's going to be run on the remote system. So my remote system that I'm connecting to is a Hyper-V server. So let's take a look at the virtual machines that are on that server. I'll type get-vm, and in pretty much every other instance of my using the get-vm commandlet in this course, I've always had to specify a computer name, but I'm not going to do that this time because there's no need. I'm already connected to a remote system, so I don't have to specify a computer name. So instead, I'm just going to use the pipe symbol, followed by select object, and I'll look at the virtual machine name. So I'll type name, and then closing bracket, and I'll press enter. And here's a list of the virtual machines that exist on my Hyper-V server. And just to prove that this really is being redirected to a remote system, what I'm going to do is type the commands that are inside the brackets, which is get-vm, select object name, but I'll do that without the remote session. So get-vm, select-object name, and I get an error message. And the reason for that is that Hyper-V isn't installed on this particular server. So get-vm isn't even a valid commandlet because Hyper-V doesn't exist on this machine. So when I ran the get-vm select object name commandlets alongside the invoke command commandlet, I really was redirecting that to my Hyper-V server. So that's how you can go about running just one command or a short series of commands against a remote machine without having to worry about establishing a full-blown remote session that redirects your entire console. Now, it might not be a big deal to redirect your entire console, but occasionally what you may find is if you're creating a script and that script needs to perform some actions on a remote system, the technique that I just showed you is something that you can include inside of the script. So that means you can do redirection inside of a script and direct some commands against a remote machine without an administrator actually having to be involved and redirect a console before the script runs or anything like that. So this is just one more tool that you can use for interacting with remote machines. So with that said, there's one more technique that I need to show you in this lesson, and that's how you can collect data from a remote system. So I'll see you in the next video. Hello and welcome back. In this video, I want to end the lesson by talking about what is one of the biggest problems, or maybe the biggest challenges rather, of working with a remote session. And that is being able to locally act on data that you've gotten from a remote system. Sometimes you may retrieve information from a remote system, but it can be really tough to be able to do anything with that information locally unless you know the trick. And this is one of those things that really comes in handy in the real world. In my own organization, for example, I've got a very elaborate script that I've written in PowerShell. And what that script does is it goes out and it checks all of my various servers to see if the hard disks in those servers are healthy or not. And then if it finds a problem, it alerts me so that I know that I've got a disk health problem. And that script wouldn't be possible if it weren't for the ability to go out, query a remote machine, and then copy the information that's been retrieved from that machine and then act on it if a certain condition is met. So what I want to show you in this video is a very abbreviated version of that. I want to show you why it's so challenging to get information from a remote system and then act on it. And then I want to show you how to get around that problem. So let's go ahead and get started. Now, for the purposes of this video, I'm going to be using a script that I've written ahead of time, and the script is 9-4. Let's go ahead and take a look at it. So here's the script. Now, you can see that the script is relatively short, but let me go ahead and step you through it. The first line is identical to what we had in the previous video. I'm creating a variable called $session, and I'm setting that equal to new-ps session-computer name Hyper-V. So I'm setting up a PowerShell session with a remote computer called Hyper-V, and I'm mapping that to a variable called $session. The next line is also identical to what we had in the previous video. Invoke command, -session, $session, -script block, and then opening brackets. Now, if you watched the previous video, you'll recall that anything between the two brackets, that's this bracket right here and this bracket right here, executes on the remote system, not on the local system. So then once those commands complete and PowerShell reaches this bracket right here, it drops back down to the local system and executes code there instead of on the remote system. So what are we doing on the remote system? Well, we've got three commands that we're executing. The first one declares a variable called $myvar, short for my variable. You could really use any variable name that you want. But I'm setting myvar equal to get-vm. Now, get-vm is a PowerShell commandlet for retrieving a list of virtual machines that are running on a Hyper-V server. So then I've got another line of code, $myvar, that's the variable containing the list of virtual machines, and I'm piping the output of that variable into select object name. So I'll get a list of the virtual machine names. Then the next line terminates the PowerShell session. So I've got exit ps session. And then at that point, the script reverts to running locally. And so we have $myvar, which is the variable containing the list of virtual machines. And then I'm piping that into the select object name command. So this line right here is completely identical to this line right here. That's going to be an important thing to remember going forward as we work with the script. Now, before I execute the script, one thing that I want to quickly mention is that if you watched the last video, you may recall that toward the end of the video, I mentioned that being able to use this technique was handy because it allowed you to script a remote session. You could create a script block, run a few lines of code on a remote system, and then return control to the local system. And that's exactly what I've done here. So hopefully you can see the benefits of being able to do something like that. At any rate, now that I've shown you what the script does, I want to save the script just in case I haven't saved my changes, and let's run it and see what happens. So I get a list of the virtual machines that are running on the remote system. So we can see the virtual machine names in this column, and we can see that they're coming from a computer called Hyper-V. And then you also see the run space ID. Now, the interesting thing that you'll notice about the output is that we only got one list of virtual machines. And if I switch back to my script, you can clearly see that there are two lines that tell PowerShell to display that virtual machine list. We have one line right here, and then we have an identical line right here. So what's going on? Well, let's break this down a little bit. What I want to do is comment out this line right here. This is the line that displays the list of virtual machines locally on my own system. So I'll save this, I'll run the script, and we get the exact same results that we had a moment ago. Now I'll switch back to my script. I'm going to get rid of this comment, and then I'm going to comment out this line. I'll save my script, and then I'll run it, and I get nothing. So what's going on? Well, let's take a look. Remember what I said a moment ago, that everything running between this bracket and this bracket executes on the remote system, not on the local system. That's the key. So we're declaring a variable called $myvar on the remote system. The local system doesn't know anything about that variable because the variable only exists on the remote system, not on the local system. So that's why when we get down to this line right here, PowerShell doesn't output anything because the local PowerShell session knows nothing about the existence of the myvar variable. That variable only exists on the remote system. So that's the problem. So how do we fix this? What if we wanted to return that list of virtual machines to a local variable so that we could take some other action on that list at a later time? Well, it is possible to do that. That's what this video is all about. So before I show you the solution, let me go ahead and just comment out this entire portion of the script. And then I want to go ahead and scroll down. And you can see that I've got a section called the fix. Let me go ahead and remove the comments from this section, and then I'll step you through it. So let's take a look at what we've got in the fix section. And I'll go ahead and save my changes just so I don't forget to do that. So the first two lines are identical to what you saw in the previous version of the script. We're declaring a variable called $session, and we're setting that equal to new PS session, computer name Hyper-V, and then we're running the invoke command cmdlet, and we're directing that toward our session, and then we're defining a script block. Now, let's take a look at the script block. First line of the script block creates the myvar variable and sets that equal to getVM. Then the next line says $myvar, the pipe symbol, and then select object name. And then the third command inside of the script block is exit PS session. So all of that is identical to what you've already seen. We're not doing anything at all different. So far, from this point all the way up to here is identical to what we had in this script. Then we get to this line right here, and this is where all the magic happens. What I'm doing right here is I'm setting another new variable. This one I'm calling local result, and you can call this variable anything that you want. This is just the name I decided to go with. So I'm setting $local result equal to invoke command -session $session -script block, and then open bracket myvar close bracket. So what are we really doing here? Well, we're establishing another remote session to the same Hyper-V server as before because I'm still using the same session variable. But at this time, I'm running a different script block. The only thing I'm doing inside of the script block is checking out the contents of the $myvar variable. But I'm mapping this entire command to a variable called $local result. So what that's going to do for me is it's going to copy the contents of the $myvar variable that only exists on the remote system. It's going to copy that to a local variable called $local result. So then in the next line, I've got exit-ps session, so I'm terminating my remote session. Then the line after that, I'm displaying the contents of that variable, so I've got $local result, and then select object name. So let's go ahead and save this, and let's run the script and see what happens. And this time we see the virtual machine list twice. So here's one list, and then here's the second list. And you'll notice that these lists look a little different from one another. The reason for that is that the first list was run on a remote system. So we have the remote computer name right here in the PS computer name column. But the second time that we chose to list the virtual machine names, we were executing a local command, so there's no need for PowerShell to tell us that we're working on a remote system. So we've effectively retrieved a list of virtual machines from a remote system, we've written that to a local variable, and then we output the contents of that local variable. So that's how you deal with data that is collected from a remote system in PowerShell. Believe it or not, PowerShell can act as a very rich reporting engine. In fact, many of the third-party network reporting applications rely on data that you can natively access yourself through PowerShell. By doing so, you can create custom reports that give you exactly the data that you're interested in. In Lesson 8, I discussed basic reporting, creating a CSV file, creating a text file, creating an HTML file, and adding color and formatting. One of the things that you probably noticed in some of the earlier videos is that PowerShell is really great about giving you information about various aspects of your system. Suppose, for example, that I wanted information about an Active Directory user. Well, assuming that I've got the Active Directory module installed, I could do something like get -80user, followed by the username. I'll just enter user1 and press enter, and I can get information about that user. So right here you can see that the user is enabled. You can see the user's given name, the username, the object class, the object GUID, and some additional information. And PowerShell can even give us more detailed information than that. If I were to repeat this command and add the pipe symbol followed by select-object, and then an asterisk, you can see that I get even more verbose information about that particular user account. And the user account is just one example. Various get commands can be used to retrieve information about practically anything that you can imagine. For example, we could do the same thing for virtual machines. Let's suppose that I wanted to see a list of the virtual machines on my Hyper-V server. I could type get-vm followed by -computer name, the name of my Hyper-V server, which just happens to be Hyper-V, and press enter, and I see a list of the virtual machines on that Hyper-V server. So for each one of these virtual machines, you can see the virtual machine name, you can see its state, whether or not it's running, you can see how much CPU resources are currently being used, the memory assigned to the virtual machine, the uptime, the virtual machine status, and the virtual machine version. And of course, you can drill down into this and get even more information. So for example, if I wanted to get more detailed information about virtual machine VM1, I could repeat the same command and add the virtual machine name. And if I just enter the command like this, then I'll only see that virtual machine, but I'll get the same information that I saw a moment ago. You can see what that looks like. But what I can do is append select-object asterisk, and I'll get much more detailed information about that virtual machine. You can see just how much information was actually returned. The amount of information is practically overwhelming. So we have very, very detailed information provided for that virtual machine. So the point being that PowerShell is good at reporting. It can pull any number of attributes related to a particular object, in this case a virtual machine, but you also saw the same technique used for a user account. And we're not just limited to user accounts and virtual machines. We can do this for just about any type of object within PowerShell. But the really interesting thing about PowerShell is that we can actually pick and choose. We can pull attributes from different types of objects and combine them into a common report. Or we can look at very specific attributes related to a common type of object. So what do I mean by that? Well, let's take a look. Let me go ahead and clear the screen. And a moment ago, I showed you a commandlet where I typed get-vm followed by a virtual machine name, and then the computer name, and the name of my Hyper-V server. And that gave me some basic information about the virtual machine. But let's suppose that I wanted to narrow this down a little bit, and I wanted to just see the virtual machine name and its running state. I could do something like this. So rather than entering an asterisk after select object, I've entered name, state, telling PowerShell that I want to look at this virtual machine, but I only want to see the virtual machine's name and the virtual machine state. And you can see what that looks like. And I can also do this without a virtual machine name. So if I wanted to get the name and the state for all of my virtual machines, then I could do that simply by getting rid of the virtual machine name and press enter. And now I get a list of all of my virtual machines followed by their state. Now, we're not just limited to displaying raw information like this. We can actually combine the techniques that I've shown you with filtering. Let's suppose for a moment that we wanted to only see a list of the virtual machines that are running. Well, let's go ahead and stop a virtual machine. I can do that by typing stop-vm, and I'll stop VM4. And it might help if I include the computer name. So let's go ahead and do that. Okay, so we have stop VM4-computer name Hyper-V. So let's go ahead and stop this virtual machine. And let me get a list of my virtual machines just to make sure that this is stopped. And we can see that virtual machine 4 is indeed turned off. So let's suppose for a moment that we have a lot more virtual machines than what are listed here, and that we're interested in seeing a list of which virtual machines are running. Well, the way that we could do that is by typing get-vm and then -computer name. The name of the Hyper-V server, the pipe symbol, and then where object, a bracket, $__state, -eq, that's equals, and then apostrophe running, apostrophe and bracket. So hopefully I haven't made any typos here. I'll press enter. And now we see a list of only those virtual machines that are running. So you can see that we had get-vm-computer name Hyper-V. So we're retrieving a list of virtual machines from the Hyper-V server, but only where the object state is equal to running. And we could do the same thing for stopped. I'll repeat the command, and I'll replace running with stopped. Actually, the state is off, not stopped. So let me try that again. And we can see that VM4 is indeed turned off. So that's how you can build filtering into your reporting capabilities. Now, as I mentioned a moment ago, sometimes you may find that a particular get commandlet doesn't provide all of the information that you need for a particular report. So when that happens, you can actually retrieve pieces of information from various get commandlets and combine them all into a single report. Now, that alone is relatively easy to do, but the problem is that a lot of times if you're simply retrieving bits and pieces of information from various get commandlets, then when you go to display that information, things get really messy. Because you notice in some of the commandlets that we've used here that the output is formatted in a very nice, neat, orderly way. But that's typically not the case when you simply retrieve pieces of information from a variety of different get commandlets and try to jam them all together. You'll find that the output is a mess. Fortunately, there is a way of getting around that problem. The trick is to create an object. So let's take a look at how that works. I'm going to go ahead and clear the screen just to get rid of some of the clutter. And I'm going to open up a script that I created earlier. And the script is 7-1.ps1. So this script is fairly straightforward. So what this script does is it retrieves some information using the get-vm commandlet that you've already seen several times throughout this video, but it also retrieves some information using the get-vm processor commandlet. So what is get-vm processor? Well, let me go ahead and switch back over to PowerShell and I'll show you. So as you've already seen, using the get-vm command followed by the name of a virtual machine and the computer name retrieves information about that particular virtual machine. And there's a lot more detailed information that you can get to by using select object. So there are loads of attributes related to this particular virtual machine that we can look at. But the thing about it is, there are pieces of information related to that virtual machine that aren't tied to that particular commandlet. So get-vm won't reveal absolutely everything about the virtual machine. So let's say, for example, that we want to take a look at the maximum CPU use, or the amount of CPU that's reserved for this virtual machine. Well, the get-vm commandlet won't return that information for us. So if we want to look at that particular type of information, we're going to have to resort to using the get-vm processor commandlet instead. Let me show you how that works. It works very similarly to get-vm. So I'm going to type get-vm processor, and I'll give it a virtual machine name and dash computer name, Hyper-V. And incidentally, I keep using the dash computer name Hyper-V parameter. You don't have to do that if the virtual machines reside locally on your system. In my case, I have a separate Hyper-V server, so I keep having to specify the dash computer name parameter just to tell PowerShell that I want to look at that remote Hyper-V server rather than looking for a local instance of Hyper-V. So let me go ahead and press enter. And so now you can see the virtual machine name, you can see the virtual CPU count, you can see whether or not CPU compatibility for migration is enabled, and you can see compatibility for older operating systems enabled. And as was the case with the get-vm commandlet, there are some additional parameters that you can look at. If I repeat the command and append select -object asterisk, and press enter, you can see that there is a lot of CPU specific information provided by this command. So let's get back to our script. What the script does is it retrieves some information from the get-vm command, which remember provides basic information about the virtual machine, but it also retrieves some CPU specific information from the get-vm processor commandlet. So with that said, let me switch back to my script and I'll walk you through this. So here's the script. And if you look at the very first line of the script, you can see that it begins with a function declaration. So I'm going to come back to this. The very first line of code that actually gets executed here is this one right here, $VMs. So I'm setting up a variable called $VMs, and I'm setting that equal to get-vm. And we actually need to append dash computer name Hyper-V. And I actually need to add the dash computer name Hyper-V to my get-vm processor commandlet as well. And let me save this. So the very first thing that we're doing with this line of code right here is creating a variable called $VMs, and we're setting that equal to the list of virtual machines on the Hyper-V server named Hyper-V. Next, we're setting up a loop, and it's a for each loop. So we're saying for each $VM or virtual machine in $VMs, the list of virtual machine. So for every virtual machine in our list of virtual machines, we're going to perform these tasks right here that are highlighted in blue. So what are we going to do for all those virtual machines? Well, the first of these two lines is $CPU, so we're creating a variable here, equals get-vm processor. This is the get-vm processor commandlet that I showed you a moment ago in PowerShell. $VM, so we're looking at the virtual machine processor information for the current virtual machine on the list on the computer called Hyper-V. Next, we have display-output. Now, display-output isn't a PowerShell commandlet. Instead, it's the name of the function that we set up at the top of the script. And we're passing the $VM variable and the $CPU variable. Now remember, $VM reflects the current virtual machine within the list of virtual machines, and then $CPU reflects the CPU information for that virtual machine. So let's jump up to our function. And as you can see, the function is set up to receive $VM and $CPU. Now, what we're doing within the function is we're setting up a variable called $obj, that's short for object. And I'm setting $obj equal to new object, and I'm setting the object type to PS object, so a PowerShell object. Next, I'm adding some members to that object. So I've got $obj pipe symbol, and then add dash member. And this is consistent on the next 4 lines of code. So no property, and then VM name. And then I'm setting VM name equal to $VM, that's the current virtual machine, .name. So we're creating a property called VM name, and we're setting that equal to the virtual machine name. And then we're doing the same thing on the next line. We're creating a property called CPU count, and we're setting that equal to the number of virtual CPUs that have been allocated to that virtual machine. Next, we're creating a property called maximum, and we're setting that equal to the CPU maximum for the virtual machine. And then finally, we're creating a property called reserve, and we're setting that equal to the CPU reserve for that virtual machine. And then at the end of the function, we are writing the output of that particular object that we've created. So this will cause the object to be displayed, and that's where our report comes from. And I just noticed one more correction that I need to make to the script before I run it. I need to add .name to the end of $VM, because we're passing the virtual machine name to the get VM processor cmdlet rather than passing the entire virtual machine object. So I'm going to go ahead and save my script, and I'll switch over to PowerShell, and let's go ahead and run the script. And you can see the results of the script. Now, admittedly, this display is somewhat unimpressive, but keep in mind what we've really done here. We have retrieved information from a variety of get cmdlets, in this case 2 different get cmdlets, and we've combined all of that information together onto one report. And we could even add information from a number of other get cmdlets. We could apply filtering. So there's really no limit to what we can do. And then some of the other things that we can do with regard to reporting is we can take this information and we can dump it out to a CSV file or even to an HTML-based report. And those are things that I'm going to be talking about in some of the following videos. Hello and welcome back. In the last video, I showed you how to create a basic report using PowerShell. Now I want to switch things up over the next few videos and show you how to export that information to a variety of file types. So with that said, let me go ahead and open up my scripts folder. And I'm going to open up the script 7-2.ps1. Now, one thing that I want to be sure and let you know right up front is that all of these scripts that I'm about to show you over the next few videos do the same basic thing. They create exactly the same report. But having said that, I'm going to switch up the way that I do it just a little bit from one video to the next, just to kind of illustrate the point that there's more than one way of doing things. Also, some of these reporting types, you have to jump through a few hoops to really get the report to look the way that you want it to. So you may see some differences from one script to the next just because of some of those requirements. So let's go ahead and take a look at what this looks like. So here's our script, and for the most part, this is identical to what you saw in the last video, so I'm not going to step through every single line like I did in the last video. Let's instead just take a look at what we've done different here. So as before, I set up a variable called $VMs, and I set that equal to get-vm computer name Hyper-V. So we're retrieving a list of virtual machines off of our Hyper-V server, and we're assigning that virtual machine list to a variable called $VMs. Then, as before, I set up a for each loop, and I'm looking at each VM in the list of VMs, or each virtual machine in the list of virtual machines. And then I'm also setting up a $CPU variable so that I can retrieve that virtual machine processor information. And then once I acquire all of that, I'm calling my function display output, which you can see up here. And that display output is what creates that object variable with all of the different pieces of information that we included in our report. As you'll recall from the previous video, this included the virtual machine name, its CPU count, its CPU maximum, and its CPU reservation. And then we formatted all of that into an object and used the write object commandlet to display that object. So, having said that, we're doing one thing that's a little bit different here. If you look down right here, you can see where we're calling the function, and then I'm passing the $VM and $CPU variable to that function, just like what we did before. And then I've got the pipe symbol, but then I've got export-CSV. So what this is saying is that PowerShell is going to call the function, it's going to assemble that object, and then when it returns from that function, it's going to export the function information to a CSV file. And we're saving that CSV file to the path c:/data, and we're calling the file 7-2.csv. So this is really simple to do, but there are two parameters that I'm using that you need to be aware of. The first one is no type information, and then the second one is append. Now, the no type information parameter is a little bit difficult to explain, so it might be easier to just show you what it does. So with that said, let me go ahead and switch over to PowerShell, and I'll run the script. And the script is completed. So what I'm going to do is open up File Explorer, and I'm going to go to the data folder. And here's the 7-2.csv file that we created. So you'll notice that the very first line of the file is a header line. So this displays the columns of information that we're including in the file. We have the virtual machine name, the CPU count, the maximum, and the reserve. And then beneath that, we have information for VM1 through VM5, our 5 virtual machines. So the important thing that I want you to pay attention to here is this very first line, because that line is a header row right now. So with that said, let me close this out, and I'm going to delete this file. Then I'm going to switch back over to my script, and what I'm going to do is copy this line, and I'll paste it right here. But the one thing I'm going to do different is put a comment symbol in front of the line. That way I can preserve my original line. So then I'm going to go back here and I'm going to get rid of the no type information parameter. And then let me save out the script. And let's run this again. So the script finished. Let me go back to my data folder and let's take a look at the file. So now we have a type line as the first line. The line with the column header still exists, but that line is our second line. Now, the reason why this is a problem is because most of the time, if you import a CSV file into a program, that program is going to expect the very first line of the CSV file to define the column headers. It's not going to be expecting this type line. So it's a really good idea to go ahead and filter out that type line if you possibly can. So let me switch back to my script. Actually, let me go ahead and delete this file first. And then I'll switch back to my script. I'm going to add this no type information parameter back. And then what I'm going to do instead is I'm going to get rid of the append command. Now what the append command does is it tells PowerShell that every time a new item needs to be added to the file, it should append that item to the existing items rather than just completely overwriting the file. So let's take a look at what happens if I get rid of that append parameter. I'll go ahead and save this out, and let's run the script. And I'll go to my data folder and open up the CSV file. And so you can see that because we added that one parameter back, we now have our column headers and we no longer have that type row. But the only virtual machine that's listed is VM5. And the reason why that happened is because I got rid of the append parameter. So VM1 was actually added to this file, But then when VM2 was added, VM2 overwrote the VM1 line. And then VM3 overwrote VM2, VM4 overwrote VM3, and then eventually VM5 overwrote VM4. So we're left with one row of data in our file. So that's why the append parameter is so important. So let me go ahead and close this out, and I will delete 7-2.csv. And I'm going to go ahead and just get rid of this line. And I'll get rid of the comment symbol and save this and switch back to PowerShell, and we'll run the script one more time. And now if I open it, you can see that the type line is gone and all of our virtual machines are back and everything looks exactly the way that it should. So that's how you create a CSV file in PowerShell. Hello and welcome back. In the last video, I showed you how to use PowerShell to create a CSV file. Now, I want to show you how to use a very similar technique to create a text file. So let's go ahead and get started. I'm going to open up File Explorer, and I'll go to my scripts folder, and I'm going to open up 7-3.ps1. And here's the script. Now, right away, you can tell that my function has changed just a little bit. It's a little bit longer than it was before. I'll come back to that in 1 second. I'm going to scroll down, and you can see that for the most part, the body of the script really hasn't changed all that much. But let's take a look at what we're doing. So I'm starting out by defining a variable called $A, and I'm setting that equal to null. Then what I'm doing is I'm saying $A, the pipe symbol, and then outfile c:/data/7-3.txt. So what are we doing here? Well, what these two lines of code right here do is they create an empty text file. And the reason why I do that is because of something that you saw in the previous video. You'll recall that when we created a CSV file, we had to use that append switch, otherwise every new record overwrote the CSV file. Well, we run into the exact same problem when we create a text file, because if we simply use the outfile command, like what you see here, then every time we try to write data to the text file, then that outfile commandlet is going to overwrite the text file. So we can't do that. Instead, what we have to do is we have to initially create that text file, and that's what I'm doing here. I'm creating an empty text file, that file being called c:/data/7-3.txt. And then as I add data to that text file, I do that by using a commandlet called add content. I'm getting a little bit ahead of myself, but you can see the add content commandlet right here in blue. So I'm setting $A to null, so $A doesn't equal anything. And then I'm writing that null value, or nothing, out to my text file, c:/data/7-3.txt. So now we have an empty text file residing on the hard disk in the c:/data folder. What are we doing next? Well, the next thing that we do is set up a variable $VMs, and I'm doing exactly the same thing that I did in the last video. I'm setting that equal to get-vm computer name Hyper-V. So I'm setting the $VMs variable equal to a list of the virtual machines that exist on my Hyper-V server. Then after that, I'm setting up a for each loop. So I'm looking at each virtual machine in the list of virtual machines, and the logic for my loop is essentially the same as what you saw in the last video. I'm creating a variable called $CPU, and I'm setting that equal to get_VM_processor for the virtual machine that we're currently examining. And then I'm calling the display output function, and I'm passing the $VM variable, which is the current virtual machine name, and the $CPU variable, which has the CPU information for that virtual machine. So I'm passing those two variables to my display output function. So now let's take a look at the function. I pointed out a moment ago that this function seems to have gotten a little bit longer. But for right now, don't pay too much attention to this line or some of the other lines, because you'll notice that those lines are commented out with the pound sign. So these are things that I'm going to take a look at a little bit later on. For right now, The function is more or less the same as what we had in the previous videos. We're setting up an object variable, we're setting that equal to new object of type PS object, and then we're adding members to that object. So we have add member, no property, VM name, $, VM.name. So all of this is exactly what you saw before. The only thing that's a little bit different is that when we get down here to the write output portion, we're not just returning to the main script body at this point. I've added a pipe symbol, and then I've added add content. And remember, add content is the commandlet that adds information to a text file. And I'm telling PowerShell that I want to add that content to the c:/data/7-3.txt file. So that's it. Every time the function processes, it creates that object, and then it writes the contents of that object out to the text file that we created earlier. So let's take a look at what this looks like. I'm going to go ahead and I don't think I made any changes, but I'll hit save just in case. And I'll switch over to PowerShell and let's run the script. And the script was 7-3.ps1. So the script is finished running. Let's take a look at the file that was created. I'm going to open up File Explorer and open my data folder. And here's my 7-3 text file that was created by the script. And you can see that all of the information is in there, but the formatting is a little bit off. We have this @ symbol at the beginning of each line, and then the record set is enclosed in brackets. And then we have VM name equals VM1, CPU count equals 4, maximum equals 100, reserve equals 0. So this may or may not be acceptable depending on what it was that you wanted to do with the text file. So what if you just wanted the raw information without all of the extra stuff? Without the VM name and CPU count and maximum and reserve, without all of those titles and without the @ symbol and the brackets and that sort of thing. Well, remember those lines that I commented out. Let's go ahead and take a look at those. So let me go ahead and close this. And then I'm going to delete the text file that we created so that we can create a brand new text file. And then I will switch back to my script. Now what I'm going to do is I'm going to press enter to bring the pipe symbol and the add content line down to a new line, and I'm going to comment that out so that PowerShell doesn't run that line. Next, I'm going to go up here and let's take a look at what I'm doing. As you'll recall, we defined a variable called $obj, and we set that equal to a new object of type PS object. Then we began adding members to that object. And the first member that we added to the object we called VM name, and we set that equal to $VM.name. Well, $VM.name is actually the name of our virtual machine. So if we just want to add raw data to the text file, we can use $VM.name directly. We don't even have to worry about the object. So that's exactly what I did right here in this line that's commented out. I have $VM.name, which is the virtual machine name, followed by the pipe symbol and then add content, and then the path and file name. So I'm adding the virtual machine name directly to the file in this line. It's really simple. So let me go ahead and remove the comment symbol and let's drop down to the next one. Next we have $CPU.count, and that's literally our CPU count. And we're adding that directly to the text file by using the pipe symbol, followed by add content, and then the path and file name, c:/data/7-3.txt. I'll uncomment that as well. And then let's take a look at the next commented line. We have $CPU.maximum, so that's our CPU maximum. And again, I have the pipe symbol, and then add content, c:/data/7-3.txt. I'll remove the comment there. And then the last one, we're adding the CPU.reserve to our text file. So I'll go ahead and remove the comment from that one. And let me go ahead and save this out. And I'll switch over to PowerShell and run the script. And so this time, because of the way that's structured, we do see the output on the screen. But if I go ahead and open up my data folder, here's the text file. And you can see that the text file looks a lot different because instead of having all of that ancillary information, we just have our individual data elements and each one is on its own line. Now, certainly we could use PowerShell to manipulate this in a different way. We could put it all on one line if we wanted to, but if you're doing that, really, you're probably better off creating a CSV file. I just did this to show you that there are different ways of outputting values to a text file. So that's how you create a text file in PowerShell. Hello and welcome back. In the last couple of videos, you saw me create a CSV file and a text file. In this video, I want to show you how to create an HTML file. So the script is going to do exactly the same thing as what I've been doing in the last couple of scripts. The report is no different, but the way that I create the report varies just a little bit. And the reason why I did that is because PowerShell is really picky when it comes to creating HTML files. So I had to kind of move some things around a little bit just to be able to make PowerShell happy. So you'll see what that looks like. Let's go ahead and open up the script. I'm going to open up File Explorer and I'll go to my scripts folder and let's go to 7-4.ps1. So here's the script. So if you look at the script body, you can see that I begin by doing exactly the same thing that we've been doing all along. I've got $VMs equal getVM dash computer name Hyper-V. So I'm retrieving a list of all of the virtual machines on my Hyper-V server, and I'm writing that virtual machine list to a variable called $VMs. Now, in some of the other videos, I set up a for each loop. This time, I'm doing things just a little bit different. Rather than setting up a for each loop, I'm treating the $VMs variable like an array. You see the @ symbol right here. That's what I'm doing. So what I'm doing is I'm telling PowerShell that I want to pass that entire array up to my function. Remember, the function is called display output. So here's my function right here, function display output, and I have the bracket indicating that we're beginning the function block. Now, one thing that I'm doing a little bit differently here is you'll notice the word process. Now, process is something that PowerShell uses. It's a block within a function, and you can see my comment right here. The process block is used to provide record-by-record processing for the function. So we're doing record-by-record processing. We're passing the entire array up to the function, and then we're processing that on a record-by-record basis. So having said that, the actual logic within the function that I've highlighted in blue is identical to what we've done before. I haven't really changed anything significant right here. And then I've got the write output line for the object that we've created. So this is what displays the object that we've created once we've added all of the members to that object. So then at that point, the function ends, we're returned back to the script body, and then we're taken to this point right here. And you can see that we have a line convert to HTML. So this is going to take all of that data that gets returned to the main script body, and it's going to take that data and convert it into HTML format. Then we're writing that HTML data out to a file by using out-file. And I'm saving that in the c:/data folder, and I'm calling it 7-4.htm. So let's take a look at what this looks like. I'll go ahead and save this out in case I made any changes. And then let's go ahead and switch over to PowerShell. I'll type /7-4.ps1. The function has completed. So let's take a look at the data folder. And we have a file called 7-4.htm. I'll go ahead and open that up. And you can see that we now have our report in HTML format. So that's how you create an HTML file in PowerShell. Now, one of the things that I'm sure you've noticed is that this report is extremely bland. It probably doesn't look like any web page that you would want to visit. But that's okay, because this is just raw data. Because this is an HTML format, we can do anything that we want to spice this up and make it more visually appealing. And I'll show you how to do that in the next video. Hello, welcome back, and welcome to what is sure to be one of the shortest videos in this entire course. In the previous video, I showed you how to take a report and export that report in HTML format. But as you may recall, that web page that we created looked really, really bland and boring. And in this video, I just want to show you how to add some formatting to that. So having said that, let me go ahead and switch over to my data folder. And let's take a look at that report. So here's what the report that we generated in the last video looked like. So all of the data is there. We have VM1, VM2, VM3, VM4, and VM5. And we have the CPU information for each one of those virtual machines. But it's just black text on a white background. There's really nothing exciting or visually appealing about this. But we can create more visually interesting HTML code using PowerShell. The trick is to just write HTML style data out to the HTML file that we're creating. So let's take a look at how to do that. I'm going to go ahead and close this out. And I'm going to switch over to my scripts folder. And actually, let me close the script from the last video. I'll go to my scripts folder, and I'm going to open 7-5.ps1. So here's the script, and the vast majority of this is identical to what you saw in the last video. I didn't change anything at all inside of the function, so every bit of this is exactly like what we had in the previous video. Now let's take a look at the script body, and immediately you'll notice that this is quite a bit different than what we had before, but I'm not doing anything overly complicated here. I begin by creating my $VMs variable. This is identical to what you saw in the previous video. I'm setting $VMs equal to get-vm computer name Hyper-V, so I'm retrieving a list of my Hyper-V virtual machines off of my Hyper-V server. But then, before I go and call my function, I'm creating an HTML style. And incidentally, you'll notice that the line where I call the function is the same. I've still got the @ symbol in the VMs, and I'm still calling display output. I'm still using convert to HTML. So every bit of that in blue is identical to what you saw in the last video. The main thing that's different is this section right here. So as you can see, I'm setting up a variable called $A, and I'm setting that equal to style, and that's between a less than and greater than symbol. So this is an HTML style tag. So then the next several lines set $A equal to $A plus. So what I'm really doing here is I created a text string, and that text string is assigned to the $A variable, and right now it just contains style inside of a greater than and less than symbol. So it's a style tag. But then what we're doing is we're manipulating that text string by adding additional text blocks to it. So the first text block that we're adding is HTML code for setting a body background color. And I'm setting the body background to dark sea green. And then after that, I'm defining some style elements for tables. So you can see that right here. And I'm setting things like the border color. And let me go ahead and scroll over just a little bit. And you can see that I'm also setting some background colors right here and right here. So I'm just setting some basic HTML style elements. I'm not going to step through every single one of these because this isn't an HTML course, and HTML does tend to be very well documented. But that doesn't mean that I'm going to leave you without any help. You'll notice that I've got two lines right here that are commented out. So the header code that I've used right here is adapted from something on the Microsoft website, and that URL is right here. I've included it in the comment. So I'll just show you what this looks like. I'll go ahead and copy this, and I'll open up a web browser, and let's paste this. So you can see that this takes me to a Microsoft site that talks about creating formatted HTML output. And so they go through the use of some of the different style tags that I'm using in this script. So let me go ahead and close out that. And then the next thing that I've got linked here is a place where you can go and get the various color names, because I'm guessing that you're probably going to want to use a color set of your own rather than just using what I've used. And you can get a list of all of the color names at this website right here. Now, certainly this isn't the only website that lists the HTML color names, but it's one of the better ones that I've found. So even though I don't have any affiliation with this particular website, I wanted to go ahead and point it out in this video just because I think they did a good job. So I'll go ahead and paste and go out to that site. And so you can see samples of each color along with the color name. So you can use color names like aqua or beige or blanched almond and so on and so forth. And as you can see, there are a lot of different colors that you can choose from. So let me go ahead and close this out. Now, after we've defined our HTML tags, the next thing that we have is our main line that calls the display output function. So we have at VMs, we're passing our list of virtual machines as an array up to the function. And as I mentioned, the function itself hasn't changed at all. And we call that function by calling display-output. And then we have convert to HTML. As I mentioned, all of this is the same as what I did before, but we do have one thing that's a little bit different. Rather than saying convert to HTML and then immediately providing the file name, I've included a couple of extra elements. I have -head and then $A. And remember, $A is our style sheet. So all of those style elements were written to the $A variable. So we've got -head, $A. Then we have -body. So we're defining the HTML body. And then for the body, I've got H2 inside of a less than greater than sign. So we're using heading 2 and displaying the words virtual CPU information. And I should have a slash here to close out that heading tag. Let me save this. And then after that, we have a pipe symbol followed by out file, and then the path and file name. So that's going to be c:/data/7-5.htm. So let's go ahead and take a look at what this looks like. Let me make sure I've saved this. I'll go to PowerShell and I'll run the script. And that's ./7.5.ps1. And let me go to my data folder. And we have our 7-5.htm file. So just as a reminder, here's what the HTML file looked like before. So just black and white. And then here's the file that we just created. So as you can see, there is a big difference. And really, I just kind of used a sampling of what we can do with HTML. Really, through that text string manipulation that I showed you, you can add any HTML elements that you want. So you can create really nice, visually interesting. So that's how you create formatted HTML output in PowerShell. Although text-based reports like the ones that I showed you in Lesson 8 are useful, you can use PowerShell to create graphical reports. In fact, it's possible to use PowerShell to build full-blown GUI dashboards. I'm not going to go as far as building a dashboard, but I do want to show you some of the basics of creating graphical charts. In Lesson 9, I cover creating a simple chart, changing the chart type, and importing data into a chart. Hello and welcome back. In some of the previous videos, I showed you how to create various types of reports using PowerShell. Now, PowerShell is primarily known as being a text-based environment. After all, PowerShell commandlets are entered at the command line. But believe it or not, you can create GUI-based applications using PowerShell. The trick is to tap into the proper .NET assemblies, and that will allow you to build full-blown GUI-based applications using PowerShell. And as a matter of fact, we're even going to go into that a little bit in Lesson 10. But for right now, what I want to do is I want to take some of what we did in the previous chapter and apply that to GUI-based reporting. More specifically, what I'm going to be doing is showing you how to create charts using PowerShell and .NET. So let's go ahead and get started. What my plan is to use this video to show you how to create a basic chart using PowerShell and .NET. We're not going to go into anything too crazy in this video. I just want to show you the basics. Then what I'm going to do in the second video in this lesson is come back and bring in the same script that I'm using in this video, but I'm going to break it down a little bit. I'm going to start changing some values and show you what types of effects those changes have on the chart that is created through that script. And then in part 3 of this video series, what I'm going to do is take everything that we've learned in the first 2 videos in this lesson, and then I'm going to apply that to a real-world situation. I'm actually going to import real live data from some Hyper-V virtual machines and report on that data using charts. So we've got a lot to get done. Let's go ahead and get into it. So I've created a script that's going to generate a simple chart. Let's go ahead and take a look at the chart, and then we'll get into the script. So let me go ahead and launch my script. And here's what the chart looks like. So for the purposes of this video, let's pretend that we work for a company that makes widgets. Now, if you're unfamiliar with the term widgets, it's basically just a generic word that means some meaningless object. So we're creating these objects, and they're of different colors: red, blue, yellow, purple, and green. And we're creating a chart to show how many we've sold within a given period of time. So if you look at the chart, you can see that we have a legend right here by the mouse pointer that shows widget sales. Down at the bottom, we have the number sold, and we have the color of the widgets: red, blue, yellow, purple, and green. And then on the left side of the chart, we have the price, and the price column is numbered. And then at the top, we have a title, in this case, widget sales. We also have a title for the window itself, and the window is just called PowerShell chart. So let's take a look at the script that was used to create this. So I'm going to open up my scripts folder, and I'm going to open up the 8.1 script. And here's the script, and this is going to be one of the lengthier scripts that we've covered so far in this course. But let's go ahead and break it down and take a look at what we have. So the script begins with the comment, load assembly. Now the comment doesn't do anything, obviously, and then the next line beneath that loads the .NET assembly that is necessary in order for creating the chart, or the data visualizations as Microsoft likes to call them. Now this brings up an important point. You have to have .NET installed on the system in order to do this. So if you want to check and see if .NET is installed on your system, you could do it through PowerShell. I'm just going to go ahead and use Server Manager. What you would do is click on the Start button, and then go to Server Manager. And then once everything's loaded, just go up to Manage and go to Add Roles and Features, and click Next, 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 and then you get to the Features screen. And you can see that in this case, .NET Framework 4.8 is installed. And that's good enough for what we need to do. .NET 3.5 will also work. So I'm going to go ahead and cancel out of this. And I'll close Server Manager. And let's go back to the script. So as previously mentioned, this line right here loads the necessary .NET assemblies. Now there are actually two different assemblies that you have to load: forms and data visualization. And I see a lot of people do this with 2 lines of code, which is totally fine to do. But if you load the data visualizations assembly like what I'm doing here, it will automatically load the forms assembly as well. So this line right here is really all you need. Now, what is data visualization in forms? Data visualization is the component that allows us to make the charts. It contains all of the charting logic. Now, forms is what you use whenever you're going to create a graphical application using .NET. And you're going to see forms used extensively in Lesson 10. But for right now, all we really need to know is that you have to load this assembly, system.windows.forms.data-visualization, in order to create charts within PowerShell. So then the next section that we have, which begins right here, is where we create a chart object. Now, within this script, we're going to be creating several different types of objects. So the way that this works is we create an object, and then we begin assigning attributes to that object. So let's take a look at what we're doing here. I'm beginning by defining a variable, $chart1, and I'm setting this equal to a new object, and that object is of type system.windows.forms.data-visualization.charting.chart. And you can see all of that right here. So we've created a new object and assigned that to the variable $chart1. And incidentally, the reason why I'm using the name $chart1 is because you can create multiple charts within a single script. Charts generally have to have a name, so $chart1 is going to be the name of the chart that I'm creating. So then we begin assigning some attributes to that chart. So we're assigning a width attribute, and we're setting the width equal to 500 pixels. We're setting a height attribute, and we're setting the height equal to 450 pixels. And then we're setting a background color. And you'll notice that this says back color, not background color. And this is just the syntax that we have to use. And I'm setting the background color to white. And you can obviously set this to anything that you want, and we're going to play around with that a little bit in the next video. So let's go down to the next section. The next section is where we assign a title. Now you'll notice that I have the word void right here. Void is actually part of .NET. It's not part of PowerShell. But what void does is it tells a script that you want to hide the output from that particular command. So let me show you what happens if we remove void. If I go back to PowerShell, you'll notice that when we ran our script, there was no visible output aside from the chart that was created. I'll go ahead and close out the chart. We'll return to PowerShell. And if I run this again, there's no visible output aside from the chart itself. So let's go ahead and remove void. And we'll run the script again. And this time you can see that there's a lot of different information being output. And you can actually use this information to your advantage to help formulate your script and customize the chart that you're creating. But for right now, I'm going to go ahead and close this out. I'm going to go back to my script. And I'm going to go ahead and put void back in just to keep things nice and clean. So what is the title section doing? Well, we begin by referencing chart 1. Remember, chart 1 was the name of our chart. And then we're adding an attribute called titles. And we're going to call this particular chart widget sales, which you can see right here. So we've added a title to the chart through this line of code. Then we have two more lines. We have a line that assigns a font to the title. We're using Arial 13 point in this case. Again, you can use anything that you want. And we're also specifying a font alignment in the next line. So we have $chart1.titles, and then we have alignment, and I'm setting the alignment to top left. Again, you can use whatever you want right here. So then we go to the chart area, and you can see the chart area section right here. Now you'll notice that with the chart area section, we're creating a brand new variable, and I'm calling this one $chart area. And we're going to begin by creating another new object. So this time, our new object is going to be of type system.windows.forms.datavisualization, .charting, .chart area. So we're creating a chart area object. And the first thing that we have to do is assign a name to that chart area. And we do that through the second line of code right here. Chart area.name equals, and so the name that I'm using is chart area 1. Then I'm going down and I'm assigning a y-axis title, and that y-axis title is going to be price. I'm assigning an x-axis title, and the x-axis title is going to be number sold. And then I'm setting some intervals. I'm going to use interval 1 for both the x-axis and the y-axis. So with that said, let me go ahead and pause for a moment. I'm going to save the script since I did make a change with void earlier. And let's go ahead and rerun the script. Now, when I run the script, you can see our axis titles right here. Here's price, here's number sold, and those increments that we were talking about refer to the grid lines. So in this case, the number of green widgets sold was 7, and you can see that we have 7 squares right here because our increment was set to 1. So let's go back to the script. And then the last thing that we have in the chart area section is $chart1.chartareas.add chart area. So what we're doing at this point is we're taking that chart area object that we created with all of its attributes, such as the interval, the title, etc., and we're taking that object and then we're adding it to chart 1. And as you'll recall, chart 1 is the chart that we began creating in the previous section. So if I were to scroll back up, you can see that we have all of these references to chart 1. So chart 1 is an object that represents a chart. The chart area is another object that gets added to that chart called chart 1. So what do we have next? The next section is the legend section. And we can actually create a legend that goes with the chart. So if I switch back over to my script again, you can see that we have a legend right here. We just have a splash of blue and we have the words widget sales. Now, in this case, the legend is kind of meaningless because we've only got one type of data on the entire chart, so we really don't even need a legend. But for more complex charts, having a legend is really helpful. And it's super simple to create a legend to go with the chart. So let's take a look at how that's done. So here you can see I'm creating a variable called $legend, and I'm setting that variable equal to another new object. And this object is of type system.windows.forms.datavisualization, form.charting.legend. So that's the object type that we're creating. And as was the case with the other objects that we've created, we're adding some attributes to that object. Starting with name, we're going to call this legend. And then we take the legend that we've created and we're adding it to that $chart1 object that we created earlier. The next section is data sources. And I'm going to scroll down just a little bit. Now, data sources is where we create the data that is actually going to go onto the chart. Now, because I was trying to keep everything really simple for this particular script, I just manually created a data source. You can see that we've got a variable called $DataSource1, and I'm setting that equal to red equals 5, blue equals 9, green equals 7, yellow equals 2, and purple equals 6. So I'm just putting all of my raw data right here, so it's hard-coded into the script. Now, when we get to the third video in this lesson, we're actually going to pull in live data from somewhere else, but for right now, it was easier just to hard-code the data so that way we could have less complexity in the script. So let's move down to the next section. Sample data series. So what are we doing here? Well, once again, we've got a void statement, and that void statement just exists to keep the output nice and clean so that we can hide the output that would otherwise be generated. And you can see that once again, we're referencing $chart1. That's the chart object that we created way back in the beginning of this script. And so we're creating a series. A series means a data series, and you can have multiple data series in a chart. So if you've got several different types of data that you want to mix onto one chart, you can do that by creating multiple data series. And in the third video in this lesson, I'm actually going to show you how to do that. We're going to combine two different types of live data into a single chart. But for right now, we're just going to deal with a single series. And you can see that I'm adding that series through the word add right here, and we're calling that series widget sales. So then we reference the widget sales series in all of these commands right here, and we set some attributes for that widget sales series. Here we define what type of chart, and this is going to be a column chart. Now, if I switch back to the chart for a second, to me, when I look at this is a bar graph. That's what I was always taught in school that this is called. But if you set the chart type to bar, then all of these bars are going to be presented horizontally rather than vertically. So if you want vertical bars, it's called a column. If you want horizontal bars, it's called a bar. And we'll get into some of that in the next video. You can also set the border width. You can set, is the legend visible or not? And right now this is set to $true, so the legend is visible. You set what chart area you want to include, and I'm referencing chart area 1. Remember, we set that up earlier. You specify what legend is going to be associated with this particular series, and I'm going to reference legend, which we created in one of the earlier sections. We can set the color of the bars, and then our data points. So let's take a look at the data points. So we have .points, .data bind xy, and then in parentheses, we have two different things, dataSource1.keys and dataSource1.values. So what does this mean? Well, this is where we actually add the data to the chart. If you go back to that line where we hard-coded the data, you'll recall that it was called dataSource1, as is highlighted in blue right now. So these references here and here to dataSource1 refer to that array that we set up a moment ago. Now, you'll notice that we're referencing keys and values. This array that we created earlier is a key-value pair. So our keys are the colors in this case. Red is a key, blue is a key, green is a key, yellow is a key, and purple is a key. The values are the numbers that are assigned to those colors or keys. So 5 is a value, 9 is a value, 7 is a value, 2 is a value, 6 is a value. So for the very first one, red equals 5, what we're doing is we're adding red as the key and 5 as the value. And that's going to be a data point on our chart. So that's how we get data into the chart. So then if I scroll down a little bit, the very last thing that we have to do is to display the chart on a form. Now, as I mentioned earlier, a form is what PowerShell uses to create a GUI display. And technically, it's not even really part of PowerShell, it's part of .NET, but a form is what's used nonetheless. So what we have to do is to create a form. And so the very first thing that I'm doing is I'm creating a variable called $form. And once again, I'm creating a new object. This time, the object type is windows.forms.form. So once we've created that new object, we begin adding attributes to that object. So the first thing that I'm adding is text, and the text that I'm adding is PowerShell chart. Now the line of text refers to the title that's going to be assigned to the window. So what do I mean by that? Well, the Windows operating system gives every open window a title. For example, right now I've got Notepad open, and you'll notice that the title right up here by my mouse pointer is 8-1-Notepad. That's the window title. And the same thing happens with our chart. You can see that the window title of the chart is PowerShell chart. So that's where that comes from. Then just beneath that, we have form.width and form.height, and both of those are set to 500. Now it's important to remember that this refers to the window size, not to the chart size. So if I were to scroll up a little bit here, there's a separate setting right here by my mouse pointer for the chart width and height. In this case, the width is set to 500, the height is set to 450. But then we have separate settings down here at the bottom for the form width and height, which is totally separate from the chart width and height. I just wanted to be sure and point out that those are indeed separate. So then, the next thing that we have to do is add our chart to the form that we've created. And I do that with this line right here, form.controls.add, and then we're adding chart1. Remember, chart1 is the name of the chart object that we created earlier in the script. Then we have $form.add underscore shown, and we're activating the form. That's what causes the form to actually be displayed on the screen. And then the last line is $form.showDialog. So these last two lines right here are really just used to display the form on the screen. So that's just a really quick explanation of how charting works in PowerShell. I'm going to come back in the next video, and we're going to start changing some of the values in the script so that you can get a feel for some of the different customizations that you can make as you create charts with PowerShell. So that's it for this video. Thanks for watching. Hello and welcome back. In the last video, I showed you how to use PowerShell to create a simple chart. What I want to do in this video is take the exact same script that we started with in the last video and then drill down into it a little bit. I want to make some changes in that script and show you the effect that those changes have, so that way you can get a feel for some techniques that you can use to customize the charts that you create in PowerShell. So just to show you what we've got, I've created a script called 8-2, and if I run that script, you can see that it produces exactly the same output as what we had with the 8-1 script that I used in the previous video. The only real difference in this script and the 8-1 script is that in this script I've added a few lines that are currently commented out, just so that I can uncomment those lines to show you what those modifications do, and that just saves some typing, so that way you're not waiting for me to finish typing a line and watching me make all kinds of typing mistakes and things like that. It's just easier for everybody that way. So let's go ahead and drill down into the script. I'm going to go ahead and close this out and switch over to Notepad. And here's my script. And the very first thing that I want to do is actually at the very bottom of the script. You can see a line that I've got commented out right here. Save the chart. And I want to go ahead and show you this line first because I know I'm going to forget about it if I don't. So as you can see, you can actually save a chart out to a JPEG file. And the way that you do that is by setting a variable $chart1 in this case, .saveImage. So $chart1 is a variable that we've already declared. It's the name that we assigned to the chart in the previous video. And I'm just appending .saveImage to that, followed by an image path and an image type. So this line is pretty simple, but there is one thing that I need to point out about it. You'll notice that the file extension is JPEG instead of JPG. And the same thing with the file type, JPEG instead of JPG. And it has to be this way. If you just put JPG, you'll get an error. So it has to be done exactly as what's shown here. So let's go ahead and save the script. And we'll go ahead and run this. And I'll close this out. And let me go ahead and open up my scripts folder. And I called it c:/scripts/chart.jpg. So if I go back to my scripts folder, we should see chart.jpg, and here it is. And in case you're wondering, Windows hides file extensions by default. We can very easily turn that on if we want to. I'll go to File, and I'll select the checkbox for File Name Extensions. And so now we can see that this is indeed a JPEG file. And if I double click on it, that opens up the chart. So we are able to save out charts into JPEG format. So let me go ahead and close this out, and I'm going to re-add the comment in front of this line and save my change. So what else can we do? Well, let's move up to the top of the script. I showed you a number of different controls in the previous video. For example, I showed you how you could adjust the chart width, the chart height. So let's go ahead and show you what that looks like. I'm just going to change the width from 500 to 200. And I'll go ahead and save that, and we'll run it. And so now you can see that the width of the chart has been heavily condensed. I'll go ahead and close that out, and I'll set this back to 500. So what else can we change? Well, right here we have a line for background color. And right now the background color is set to white, but we don't have to use white. We can use any color that we want, and you can even set the background to be transparent. Simply substitute the word transparent for the background color. I can show you what that looks like, although in this particular environment, it's not going to really produce anything noticeable. I'll go ahead and type transparent. So that's what the chart looks like with a transparent background. You'll notice that the outer edges are gray instead of white, because I did change this to transparent. But the most noticeable thing is that we didn't get an error message, so transparent is indeed a valid value. But let's try something else. I'll set the background color to yellow. And now we can see the effect of that change. I'll go ahead and close this out and set the background color back to white just to make things easier to read. And let's move on to the next section. So the next thing that we have is the title. And right now the title is widget sales. And if I switch back to my chart, I need to save my file actually. We can see widget sales displayed right here above the mouse pointer, and we can also see it in the legend. So let's go ahead and change the chart title. I'm just going to change this to My Widget Sales. And I'll save my changes and run the script. And you can see that the chart title changed to My Widget Sales to reflect the change that I made in the script. But you'll also notice that that change didn't affect the legend. The legend text is controlled elsewhere. I'll show you that in a few minutes. Also, changing the chart title didn't change the window title. The window title still says PowerShell chart, just as it always did. So let me go ahead and close this out and switch back to the script. And incidentally, we can also make modifications to the font. For example, if I were to change this to Arial 24, we should see the font become a lot bigger. And indeed it has. And we could also reposition this title if we wanted to. I'm not going to worry about doing that, but you can see that right now the alignment is set to top left. We could easily move this to the center or to the top right or wherever else we want. The next thing that we have is the chart area. So let me scroll down just a little bit. So we set a name for the chart area. It's called Chart Area 1. And then we can set the X and Y axis titles. Right now the X axis is called price, the Y axis is called number sold. And you can see price reflected right here just above the mouse pointer, and number sold shown just above the mouse pointer right now at the bottom of the chart. So making modifications to that portion of the script will simply change the text values that are shown on the chart right now, the price and the number sold, that correspond to the X and the Y axis of the chart. So what else can we change? We could change the interval. Right now the X and Y axis interval is set to 1, but we could change this to a different value. For example, if I wanted to change this to 5, you can see that there are a lot fewer grid lines on the chart because I have changed that X and Y interval. So let me close this, and I'm going to set that back to the way that it was. And in case you're wondering, there are two reasons why I'm undoing my changes as I make them. The first one is that I want to keep everything as consistent as I possibly can and show you one change at a time so that you can truly grasp what that one individual change does, as opposed to having a whole bunch of things that get changed over the course of this video. The other thing is that I'm going to try to make these scripts available to you, and I'd like the scripts to exist in their original form when you use them, so that way you can make any changes that you want or follow along with what I'm doing in the video. So that's why I'm taking the time to go back and set everything to its original value. So the next thing that we have is the chart area style. And you can see that we have two options here for chart area 3D style. We can enable 3D, and we can set the inclination of the chart area. So what does this mean? Well, 3D is fairly obvious. We can take the chart and convert it to a 3D format. If I switch back over to PowerShell and I run my script, you can see that right now the chart is pretty flat looking. So what I'm going to do is I'm going to go ahead and close this, and I'm going to switch this to 3D. And the way that I'm going to do that is by removing the comment. So we have $chart area.area 3D style.enable 3D equals $true. And this one line should convert the chart to 3D. And now you can see that our chart is indeed shown in a 3D format. So let me go ahead and close that out. And then the next thing that we can do is set the inclination. The inclination is basically the tilt of the chart when it's in 3D format. So if I remove this comment symbol right here and save my changes, and I run the script, right now this looks pretty similar to what it did a moment ago. So let's pick a different inclination value. Let's change the inclination from 50 to 10. And you can see that the angle of the chart has changed. So that's what the inclination does. I'll go ahead and close this out, and I'll set that back to 50, and I'll comment out these lines. Now, one thing that's worth noting is that in PowerShell, you can create a variety of different chart types. And even though I'm going to be working primarily with 2D charts, you can make just about any of the charts 3D, simply by enabling these two lines right here. So the next section that we have is the legend section. And I pointed out the legend a moment ago. If I open up the chart, you can see that the legend is right here, and the legend says widget sales. So let me go ahead and switch back to my script. Now, if you take a look at the legend section, you'll notice that nowhere in the legend section does it say widget sales. We have three lines in the legend section. The first one creates a new object. The second one names the legend. In this case, we're just calling it legend. And then the third line adds the legend that we've created to $chart1, which is the name that we've given to our chart. So where does the text widget sales come from? Well, it actually comes from the data series. If we go down to the very last line that's shown on the screen right here, you can see that we have a line that adds a data series to chart1, and this data series is called widget sales. And this is the name that gets applied to the legend. Now let's suppose that I wanted to change the legend to use the word today's widget sales as opposed to just widget sales. What I could do is enter the word today's right here, and then save this out. And what you're going to see is you're going to see the legend updated, but you're also going to see a number of errors appear. And I'll show you why that's the case in just a second. So let's go ahead and run the script. So you can see that the legend did indeed change. It says today's widget sales instead of just widget sales, but we got a lot of errors in the process. So why did we get these errors? Well, if I switch back to the script, you'll notice that we have all of these other lines of code that fall within the sample data series, and those also have to be updated. So I could add today's right here. And then if I scroll down, we've got all of these other lines that would also have to be updated. So I'll add today's. And hopefully I've gotten all of those lines. Let's go ahead and save this and find out. And so now we have our chart, and the legend has been updated to say today's widget sales instead of just widget sales. So let me go ahead and close this out, and I'll clear the screen just to get rid of all of those errors. And let me go ahead and set the script back to the way that it was. So now I've set everything back to widget sales. Let's just go ahead and run the script one more time and make sure we're not getting any errors before we move on to something else. Okay, and the script seems to work fine, and we've changed the legend back to widget sales instead of today's widget sales. So let me go ahead and close this. So the next thing that I want to show you is that you can create a variety of different chart types in PowerShell. Thus far, we've been working primarily with a column chart type, and that's done by this line right here. So we have $chart1.series, widget sales.chart type, and we've set that to column. But that's certainly not the only type of chart that we can create. There are any number of chart types. As a matter of fact, there are dozens of different chart types. I'm not going to go into all of those because we would be here all day if we did, but I do want to show you the chart types that are available. Right here, you can see Microsoft's documentation. And the reason I wanted to show you this is just so that you could have a look at this URL right here and access that documentation yourself if you wanted to. But take a look at the fields. All of these are chart types that you can create through PowerShell. And as I mentioned a moment ago, there are dozens of them. I haven't counted exactly how many chart types that there are, but there are probably roughly 30, 35, something like that. So let me go ahead and close this out. And let's take a look at some of the chart types that are available to us. So what I'm going to do is I'm going to comment out the line that creates a column chart. And then I'm going to remove this line right here and change this from a column chart to a bar chart. So you can see that the big difference between the two chart types is that a column chart shows vertical bars, whereas a bar chart shows horizontal bars. So let me go ahead and close this out. And we'll go back to our script. And another variation that we can create is a cylinder chart. And as you can see, a cylinder chart is essentially the same as a column chart, except that the color is displayed as a gradient. So instead of seeing solid blue, we see blue with a touch of gray mixed in. And then another chart type that we can create is a line chart. Now, a line chart probably isn't the best option for the type of data that we're displaying here, but that's okay. Let's go ahead and take a look at it. So here's what a line chart looks like. And incidentally, there are parameters that we can adjust to control the thickness of the line, the color of the line. You can fully customize this or any of the other chart types. Now, so far, we've changed the chart type simply by changing one word. You'll notice that all of these lines right here are basically identical, or at least these three lines are, except for the chart type itself, the word that's in quotation marks at the end. We have column, bar, and line. Now, when we took a look at the cylinder chart, that was essentially a column chart with a different style applied. So you'll notice that we're using drawing style rather than chart type. Now, things work a little bit differently if we want to create a pie chart. I mean, yes, we still have a line that's very similar to what we already have been using, where we set the chart type to pie. rather than to column or bar or line or something like that. But we also have a number of other lines that we can use to customize our pie chart. And this tends to be a little bit more necessary with a pie chart than with some of the other chart types, simply because a pie chart looks so different from the other types of charts that we've been working with. So let's take a look at some of the customizations for pie charts. I'm going to begin by just uncommenting this line right here and creating a basic pie chart. So let me go ahead and save the changes, and we'll run the script. And you can see what the pie chart looks like. And it's kind of funny because the data on the chart refers to widget colors. So we have a red widget, a green widget, a purple widget, etc. But those widget colors are being displayed on colors on the pie chart that don't reflect the widget color. So it looks a little funny, but that's okay. It'll work for our purposes. Let me go ahead and close this out, and we'll make some customizations to the pie chart. So the first customization that I want to make is the label style. So let me remove the comment right here. I will save this out, and let's run the script. So what we did was we set the label style to inside, which you can see right here. And what that actually did was it placed the label inside of the chart. So we have red inside of a piece of pie. We have green inside of a piece of pie. But we could also set this to outside. Let's go ahead and do that. And incidentally, when I was typing that, you might have noticed that we have one style of quotation marks here and another style right here. That isn't any kind of crazy PowerShell scripting thing. That's just the way that Notepad happened to display this. It wasn't anything that I did, but I wanted to at least point that out in case it's confusing to anybody. So let's set the pie label style to outside, and we'll save the changes and run the script. And this time you can see that the markers are outside of the pie. So let me go ahead and close this out. So the next thing that I want to show you is the pie line color. So let's go ahead and remove the comment from that line. And I'll go ahead and run the script. And when I do that, you can see that we have a line that goes from the label to the section of pie. So we have a line going from blue to the yellow section of pie, a line going from red to the blue section of pie. And again, the colors are confusing, and I apologize for that. But being that we're not working with real data here, it isn't really important. So let me go ahead and close this out. And what I want to show you is you can change the color of that line. Let's say that we wanted to change it to red. We would just change black to red. And I'll save my changes. And we'll run the script again. And now those lines are red. And that's how the line color works. So let me go ahead and close this out. And I'll switch back to my script. And I'm going to set this red back to black. And there's one more thing that I wanted to show you. Now, earlier when we were working with the other types of charts, I created a column chart and I set the drawing style to cylinder. We can do kind of the same thing with a pie chart. We can set the pie drawing style to concave. So let me show you what that looks like. Now, you'll notice that I haven't enabled 3D for this, but we can set the pie drawing style to concave and the pie chart will appear 3D nonetheless. So let's see what that looks like. I'm going to go ahead and save my changes right here. And we'll run the script. And you'll notice that the chart looks 3D. It's taking on kind of a bowl shape, which Microsoft refers to as concave. I'll go ahead and close this. And then one last thing that I want to show you is the border width. Right now, this is set to 3, but we can change the border width if we want. I'll use 10 because that's a much bigger number, and it should give us a really noticeable change. I'll go ahead and save that. And we'll run the script. And when I do that, we can see that the lines that are pointing to the pieces of pie are much thicker than they were before. So that's just a way that you can customize the thickness of the lines. So those are just some of the customizations that you can make when you're creating charts in PowerShell. Hello and welcome back. In the first video in this lesson, I showed you how to create a simple chart using PowerShell and Microsoft.NET. And then I came back in the second video and I showed you how to customize that chart. I showed you all kinds of different options that you could use. But the one thing that those first two videos had in common was that they used fake data. They used a hard-coded data set that was really meaningless. I mean, we were looking at the color of widgets and how many widgets were sold. It was completely meaningless. So in this video, I want to show you how to link a chart to real data. Now, for the purposes of this video, what I'm going to be doing is setting up some Hyper-V virtual machines and looking at CPU resource consumption for those virtual machines. Now, I'm just using Hyper-V as an example because it's an easy thing to pull data from. But you can pull data from absolutely anything that you want to. You could use a command such as get process or get service and extract data from that. You could even pull data from a SQL Server database if you wanted to. Your options are endless. I'm just using Hyper-V as an example. So with that said, let's go ahead and get started. I'm going to begin by showing you the output from the script that I created. And we're actually going to be using two different scripts in this video. So here's the output from the first script. And you can see right off that the chart looks very similar to what we saw in the previous videos, but this time we're looking at live data. What we're looking at in this chart is the number of virtual CPUs that are assigned to each of my Hyper-V virtual machines. So I've got a Hyper-V server set up, and there are 5 virtual machines that are installed on that server. And I've given them names like VM1, VM2, VM3, VM4, and VM5, just to keep things simple. So here we can see that VM1 has 4 virtual CPUs associated with it. VM2 has 1 virtual CPU. VM3 has 2 virtual CPUs. And VM4 and VM5 both also have 1 virtual CPU. So we're taking a look at the number of virtual CPUs assigned to each virtual machine, and we're plotting that information on a chart. That's all we're doing here. So with that said, let's go ahead and take a look at the script that makes this possible. So here's the script, and I'm not going to bother going over a lot of this because it's stuff that you've already seen in the last 2 videos. A lot of this is absolutely verbatim from the first video in this lesson. So what I want to do is scroll down, and I want to go to the data source section. And as you can see, this line is commented out, but this is where we initially created our data source. As you'll recall in the previous videos, we had set up a variable called $datasource1, and then we set that equal to red equals 5, blue equals 9, green equals 7, yellow equals 2, and so on and so forth. So I'm still going to be using a variable called DataSource1 in this video, but the contents of DataSource1 are going to change drastically. So let me show you what I'm doing here. In this line right here, I'm creating a variable called $VMs, and I'm setting that equal to getVM, and getVM is the PowerShell commandlet for retrieving a list of Hyper-V virtual machines. And then I'm using the -computer name parameter followed by the name of my Hyper-V server. So what this command right here does is it retrieves a list of all of the virtual machines that exist on a Hyper-V server that is aptly named Hyper-V, and then it takes all of those virtual machines and it assigns them to a variable called $VMs. The next thing that I'm doing is setting up a for each loop. You can see the loop right here. And so the way that I'm setting up this loop, I'm looking at each virtual machine in my list of virtual machines. So I'm setting up the loop for each $VM in $VMs. $VM being an individual virtual machine, $VMs being the entire list of virtual machines. So what I'm really doing here is I'm going through all of the virtual machines on the list one at a time. So what am I doing within the loop? Well, for each virtual machine, the first thing that I'm doing is creating a variable called $CPU. And then I'm setting that equal to getVMProcessor. That's a PowerShell commandlet that retrieves information about the virtual processors associated with a Hyper-V virtual machine. So I'm setting $CPU equal to get-VMProcessor. And again, I'm specifying the computer name because I am looking at a remote system as opposed to examining virtual machines that reside locally on the system that the script is running on. And I'm setting the computer name to Hyper-V. And then I'm looking at $VM.name. So what this $VM.name is the name of the virtual machine that I'm examining in the loop. Because when we use the get-vm command, we're retrieving more than just the virtual machine name. We're retrieving an entire list of attributes pertaining to that virtual machine. So one of the things that we have to look at is the name. So what I'm doing is I'm using the get-vm processor cmdlet to retrieve CPU information for a virtual machine of a specific name on a computer named Hyper-V. So what do we do next? Well, next, I'm creating a variable called $dataSource1. And you'll recall that this is the same variable name that we had initially used in our earlier scripts. You can see that right here. So I'm saying $dataSource1 equals $dataSource1 plus, and then I'm adding $vm.name equals $CPU.count. So remember, we're working with key value pairs here. So my key is going to be the virtual machine name, and then my value is going to be the CPU count, or virtual CPU count rather, that has been assigned to the named virtual machine. And then we're going to add that information, the virtual machine name and its CPU count, to $dataSource1. And then we reach the end of the loop right here. So then we process the loop again for the next virtual machine on the list. So then as I go down in the script, all of this is identical to what you saw in the first video in this lesson. The only real difference is that instead of titling this widget sales, I changed the name to virtual CPU. And so then we come down to the bottom and we display everything on a chart. And so once again, you saw how this worked. We created this chart with all of our virtual machines and their CPU counts. So we're actually pulling in live information from a system, and we're plotting that information on a chart using PowerShell. So now that I've shown you the basics of how to get live data into a PowerShell chart, I've got a second script that I want to show you. And in one of the earlier video series, I mentioned that you could have more than one data series on a chart. So what I'm going to be doing is pulling in two different types of information from my Hyper-V server and plotting both of those types of information on the chart at the same time. So I'll go ahead and close this out, and you'll notice that in my sample data series, I'm using $chart1, that's the name of my chart, .series, and then the series has to have a name. And I'm naming the series virtual CPU. So when we create another series, that series is going to have a different name. So with that said, let me go ahead and close this out, and I'll open the other script. And this script is 8-3b.ps1. So here's my script, and the vast majority of this script is identical to the one that you just saw. Let me scroll down, and here you can see my data source 1 and data series 1, and this is the same as what I showed you a moment ago. I'm using $vms equals get-vm-computer name Hyper-V. I'm setting up a for each loop to look at all of the virtual machines in the list of virtual machines. And then I'm creating a variable called $CPU, and I'm setting that equal to get-vm processor-computer name Hyper-V. And then I'm looking at the current virtual machine within the list of virtual machines. And then I'm setting up data source 1 based on the virtual machine name and the virtual CPU count. So that's the way that portion of the script works. This hasn't changed from the last script that I showed you. So I'm going to scroll down, and you'll recall that we had this data series section, and I called this data series 1, and I named it CPU count. Now we have a second data series right here. And what I'm doing here is a little bit different, because rather than simply looking at how many virtual CPUs are assigned to a virtual machine, I'm going to be looking at how much the virtual machine is consuming its CPU resources. So how much of a CPU load is a particular virtual machine consuming? So how am I going to do this? Well, before I show you what the script is doing, I need to point out that in order for this section of code right here, highlighted in blue, to work, you have to enable virtual machine resource metering for the virtual machines that you're looking at. And the way that you do that is going to your Hyper-V server, and you type enable-vm resource metering followed by the name of the virtual machine. And that will enable resource metering, and that will allow you to look at things like CPU consumption. So with that said, let's take a look at what we're doing here. I'm starting out very similarly to what I did for the other data source. I'm creating a variable called $VMs, and I'm just reusing the name here because I'm done with the $VMs variable from earlier. And I'm setting that equal to get-vm-computer name Hyper-V, and then I'm setting up a for each loop where I'm looking at $VM in $VM. So I'm looking at each virtual machine in the list of virtual machines. So this line and this line are identical to what we had for our previous data source. Now we've got two other lines here. This line sets up a variable called $CPU use. And I'm introducing a new commandlet here, measure-vm. And this is the reason why we had to enable VM resource metering, is so that we could use this commandlet right here, measure-vm. And then I'm specifying the computer name of my Hyper-V server. And again, that server is named Hyper-V. And then I'm providing the virtual machine name. But because we're pulling in the virtual machine names from a list, I can't just literally specify a virtual machine name. I have to use this variable, which contains the name of the virtual machine that we're currently looking at. So what we're doing is we're setting the $CPU use variable to a measurement of a specified virtual machine on our Hyper-V server. So then once I've done that, I come down to this next line and I set up another variable called $dataSource2. And I'm setting $dataSource2 equal to the virtual machine name and then $CPU use dot average CPU /100. And I'm just using the /100 so that I can make the data fit on the same chart as the CPU count. Otherwise, the two values would be completely out of line with one another and you would barely even see the CPU count on the chart. So by dividing the CPU use by 100, I was able to bring the two values in line with one another. So what we're really going to be looking at in the chart is relative CPU use. So then we come down to this next section, data series 2. And as you can see, this is identical to the data series 1, except that I'm using a different name here. I'm using CPU use as opposed to CPU count, which is what we used with data series 1. Otherwise, all of this is the same. And as far as actually getting the data into the series, we're binding dataSource2.keys and dataSource2.values, just as what we did with dataSource1. And what are those keys and values? The key is the virtual machine name, the value is the average CPU use. And then we come down and we display this information on the form. So let's take a look at how this works. I'm going to go ahead and switch over to PowerShell, and I'm going to run my script. And it takes just a second for PowerShell to analyze all of those virtual machines. But then after a moment, our chart is displayed. And you can see that the legend now displays two different types of data. We have blue for CPU count and red for CPU use. So for each one of these virtual machines, we can see how many virtual CPUs are installed, and we can see how hard the CPUs are working. So we've managed to extract data from a running system and then plot that data on a chart. And really, plotting the data on a chart is just the beginning. We could easily build a script that builds on this. For example, if we found that a virtual machine is consuming too many CPU resources, we could alter that virtual machine's configuration through PowerShell so that we add more resources to the virtual machine so that it's not having to work quite so hard. That's just one idea of a way that this script could be expanded. So that's it for this video. I'll see you in the next one. Although PowerShell has a reputation for being a command line only environment, it's possible to create GUI interfaces. You've already seen how to create graphical charts, but we can use the same technique to create user interface items, such as drop-down lists, buttons, and text boxes. I show you how to do all of that and much more in Lesson 10. The topics for this lesson include creating a basic GUI, adding text boxes, creating buttons, and working with drop-down lists. Hello and welcome back. PowerShell is probably best known as a command line environment. After all, throughout this entire course, we've been working with a variety of PowerShell commandlets that we've entered at the command line. Well, in spite of PowerShell being primarily a command line environment, it actually is possible to create full-blown GUI applications using PowerShell. And in this video, I'm going to show you how that works. Now, if you watched Lesson 8, you already got a little bit of a taste of that. In that lesson, we were creating charts based on PowerShell and .NET, and those charts were, of course, graphical. And we used some of the same techniques for creating those charts that we can use for creating a GUI-based application. So I want to show you what that looks like. So I've created a script called 10-1.ps1. I'll go ahead and open that up now. So here's the script. Now, at the very beginning of this course, I started out by showing you how to create a simple script that would display the words "Hello World" on the screen. And the reason why I did that is because in programming classes, the very first program that most programming students write is a short program that displays the words "Hello World." And so it kind of made sense to start this course with that. So now I'm going to be doing the exact same thing. I'm going to write another Hello World application, but this time we're going to do it graphically. And you can see right away that this is a bit more complex than what we did before. If you don't remember what we did before, let me switch over to PowerShell. All you have to do is type right host, quotation marks, hello world, and press enter, and PowerShell writes hello world. But as you can see, doing it graphically is a bit more complex. Now, in spite of the seeming complexity of this script, this is actually fairly simple when you start breaking it down. So let's take a look at what's involved in our Hello World GUI-based application. I've divided this particular application into a few different sections. In the very first section, which you can see right here, simply load some .NET assemblies. Because PowerShell itself isn't capable of building GUI-based applications. You have to tap into .NET in order to do that. And .NET is made up of a collection of assemblies. So if you want to build a GUI-based PowerShell application, you simply need to load the correct assemblies. And that's what these initial lines do. So my advice would be, don't even worry about trying to break these lines down and figure out all the semantics of what they do. Just copy these lines verbatim and you'll be good to go. But for those who might be wondering, the assemblies that we're loading are system.windows.forms because GUI applications are based on forms. And then we're also loading system.drawing. So those are the assemblies that we have to load. So the next section is a section that I called define label. I'm going to come back to this one in a little bit. I'm going to skip ahead to the next section, which I called create form. So this is a fairly long section, but we're not doing anything overly elaborate right here. I'll go ahead and step through this. So the very first thing that we have to do is to create a new form. And the way that we do that is by setting up a variable called $form, and then we're setting that variable equal to new object, and the object type is going to be system.windows.forms.form. So we're creating a form object. And once we create that object, then the next thing that we have to do is start adding attributes to that object. And that's a fairly simple process. So the very next thing that I've done here is to set a width and height for the form that we're creating. So you can see I've got $form.width, and I'm setting that equal to 525 pixels. And I've got another line, $form.height, and I'm setting the form equal to 350 pixels. So this form that I'm creating is going to have a resolution of 525 by 350 pixels. Then the next line of code sets the form border style. And this is another one of those lines that I recommend just using verbatim. There isn't really anything that you have to do here. This basically just sets the window style. Then we move down to the next line, $form.text. Now you'll notice that $form.text isn't set to hello world. And there's a reason for that. This line of code doesn't display text within the form. Instead, what it does is it creates the window title. Because in Windows, every window that you open generally has a title associated with it. For example, right now I'm using Notepad, and if you look right up by my mouse pointer, you can see that this particular window has a title of 10-1.ps1-notepad. Similarly, if I switch over to PowerShell, the PowerShell window has a title as well. It's called Administrator Windows PowerShell. So this forms.text line sets the title for the window that is going to be associated with the GUI-based application that we're building. And I just decided to call this particular window my PowerShell GUI application. You can really call it anything that you want. So the next line that I've got is $form.maximum size. And again, I'm creating a new object, and that object is of type system.drawing.size. And I set the system drawing size to 525 by 350 pixels, which you can see right here. And you'll recall that that matches the form width and height. So I recommend setting the system drawing size to match the form width and height. Then the next thing that we have is $form.startPosition, and I set that equal to center screen. So in other words, when you launch this script that we're creating and it opens this GUI-based application that we're building, where do you want the window to open up on your screen? Well, I've set this for center screen so that the window always opens up in the middle of the monitor. Then the next 3 lines are kind of optional. You don't really need them, but I went ahead and added them to the script. What they do is they control what happens if keys are pressed. Now, if you look at this line right here, this controls what happens if someone presses the enter key. And this doesn't really do anything right now, but I wanted to go ahead and add this in because it's something that I'm going to be building on later on. So let's take a look at how this works. I've got $form.add underscore key down. And key down is the control that's used for a key press. So then I've got a parenthesis, a bracket, and then if $underscore dot key code equals enter. So this line controls what happens if somebody presses enter. And you'll notice that I've got these 2 brackets right here with nothing in between. What this is essentially doing is telling PowerShell, don't do anything if somebody presses enter. You could associate this with a button press, but because this is going to be a really simple hello world application, there are no buttons. So right now, enter doesn't do anything, but you can build on this if you want to. And that's something that we'll touch on a bit more in some of the later videos. Now, the next line does do something. Here we have $form.add underscore key down. So we're repeating the exact same control. And then this time I'm checking to see if the key code is equal to escape. So in other words, if somebody presses escape, then the action that is specified between the brackets will be performed. Now, up here where we had enter as the key press, there was nothing between the brackets. But I've gone ahead and added an action between the brackets down here for the escape key. And you can see that the action is form.close. So in other words, if somebody presses the escape key, then the form is going to close, and the GUI-based application that we're building will be terminated. So then, let's come down to the next section, and this section adds a label to the form. Now, as you'll recall, when we created the form, we began by creating an object, and that's done by this line right here, $form equals new-object system.windows.forms.form. So we've created this form object, and then we've added all sorts of attributes to that object. Now, so far, all of these attributes that we've added control the window size and where the window is displayed and things like that. But we haven't added any graphical elements to the form yet, and that's what this line right here does. So the line is $form.controls.add, so we're adding a control to the form, and that control is called $label1. Now, you'll recall that we had a label section up higher in the script, and I mentioned that I would come back to that later on. So let's take a look at that. I'll go ahead and scroll up, and I've got this section right here, define label. So the very first line in this section sets up a variable called $label1. Well, as you'll recall, $label1 is the same variable name that we're referencing here. So we're adding this object that we create in the create label section. Now, why am I calling this variable $label1? Well, the reason is because if you were building a for real GUI-based application, chances are you would have more than one label. A label is what PowerShell and .NET use to display text within the form. So conceivably, you could need to display multiple blocks of text within a single application window. So you can have multiple labels. So I like to number the labels that I create just to help me keep better track of them. So here we have $label1 equals new object, and that object type is system.windows.forms.label. So I'm creating a forms label object. So now that I've created a new object, I'm assigning some attributes to that object, starting with .text. So here I have $label1, that's my label object, .text equals hello world. So this is where the hello world text is coming from. So when I run the application and it displays the words hello world, this is the line that assigns that text that's going to be displayed. Then I have $label1.autosize equal true. So I'm letting the application decide how big to make the text. If I wanted to, I could specify a font size. And then we have $label1.location. And I'm setting that location equal to new object and I'm creating an object type of system.drawing.size 100 100. So then if I scroll down to the bottom, as you saw, we are adding that label to the form that we've already created. And then the very last thing that we have to do is to display the form. And that's done with these two lines right here. And these are two more lines that you can just use verbatim. You don't have to worry about doing anything with those other than just making sure that those lines are a part of the script. So let's go ahead and run the script. I'll go ahead and switch over to PowerShell. And it looks like I'm already in my scripts folder. So I'll type /10-1.ps1. And here's my GUI-based application. So you can see I've just got what's basically an empty window displaying the words Hello World. But you'll recall earlier, I created a title for the window and I named that window My PowerShell GUI Application. So you can see that right here above my mouse pointer. And you can also see that Hello World is positioned within the window in the location that I specified. Another thing that you'll notice is that the window is displayed in the center of the screen, because within my script, I set the start position to center screen. So obviously this isn't a super sophisticated application. I mean, really all we're doing is displaying two words. But we can build on these basic concepts that I've talked about in this video, and you can start adding other elements, things like drop-down lists and buttons and pretty much anything else that you want to include in a GUI-based application. So I'll be showing you how to do that within the other videos in this lesson. Hello and welcome back. In the previous video, I showed you how to create a very simple GUI-based application using PowerShell. And that application was so simple that all it did was display the words Hello World inside of a GUI interface. There really wasn't a lot to it. Well, in this video, we're going to build on the concepts that I've already introduced in the previous video, and we're going to add some additional elements to the GUI window. Now, before I do that, I want to revisit the script that I created for the previous video, because there are a couple of things that I want to point out that maybe I didn't talk about quite as much as I probably should have in the previous video, and those things are going to be particularly relevant to what we're about to do. So with that said, let me go ahead and open up the script. So here's the script that we used for the previous video. Now, the main thing that I wanted to point out is that the vast majority of the script is just dedicated to creating an empty window. Really, the only thing that creates an element within the window, in this case that element being the Hello World text, is the define label section right here, and then the line that adds the label to the window, which is this line right here. So with that said, let me go ahead and comment out those lines just so that you can see what happens. I'll go ahead and comment out the line that adds label 1 to the window, and I'm going to comment out these label lines as well. And I'll go ahead and save this, and let's run the script. And when I run it, I end up with an empty window. So let me go ahead and close this and switch back to PowerShell. So the point that I wanted to make is the entire load assembly section and the create form section and the display the form section, every bit of that is dedicated to creating an empty window. And you're going to use those sections regardless of what your GUI-based application is doing. So the only things that this particular script included that placed elements within that empty window were the label controls. And as a matter of fact, this section right here, the define label section, that sets up elements of the label. I'll go ahead and uncomment this. But really, it's this line right here that actually adds the label contents to the form. As a matter of fact, if I were to save this right now and run the script, then you can see that the application is still blank in spite of the fact that I uncommented all of those lines in the define label section. So the only line that's commented out right now is this line right here. So this is what actually places the label on the form, is this line right here. So that's one of the things that I wanted to talk about before we get into the next script. The next thing that I wanted to talk about is that every element that you add to the GUI requires a unique name. In this case, that name is $label1. And if I scroll up, you can see that we started out by declaring a variable called $label1, and we set that variable equal to a new object of type system.windows.forms.label. So we're creating a label object, we're adding attributes to that label object, and then we're adding the label to the form. That's how this works. So the point being that the form is modular. You've got these same basic elements that every form is going to have in common just to be able to display an empty window. And then you create objects that you then link to that form, and those objects are what put text or buttons or any other graphic elements onto the screen. Now, one more thing that I wanted to point out before I move on to the stuff that I want to show you in this video is this line right here. And I didn't discuss this line quite as well as I should have. Now, what this line does is it controls where within the GUI window the element that we're creating is going to be placed. So even though the object that we're creating is of type system.drawing.size, these numbers right here have nothing to do with size. This is a position within the window. This is 100 pixels by 100 pixels. And remember, this isn't the position on the monitor as a whole. This is the position within the window. So it's 100 pixels to the right and 100 pixels down from the corner of the window. So that's how we're setting the location where this particular element, in this case a label, is going to appear on the screen. So let me just go ahead and run that script one more time, or I guess I've still got it open, or I've got the empty version open. Let me go ahead and save this. And we'll run the script one more time. And you can see that the text hello world doesn't appear in the center of the window. And the reason is because of that location, 100, 100 that I showed you. So now that I've shown you those particular aspects of how this script works, I want to move on to a new script that I've created. So let me close that out. And I'll close out the previous script. And then I'll go to File Explorer, and I want to open 10-2.ps1. So here's the new script, and what I'm doing in this script is just adding some additional elements to the window that we've already created. So the bulk of the script is identical to what you've already seen. So we have the load assembly section up at the top, that's identical to the previous script. Then we have a define labels section, which is also identical. Then we begin creating label 1. Now I've made two changes to this section. First, I've changed the label text. You can see that whereas it used to say hello world, now it says hello world dash the first label. And I've just done this for clarity because we're going to add multiple labels to the window. And I want to be able to differentiate very clearly between one label and the next. The other change that I've made is in the position. Whereas this label used to reside at 100, 100, now it resides at 100, 50. So I've moved it a little higher up in the window. Then the next thing that I've done is I've created a second label. As you'll recall, I said that every graphical element that you add to a form has to have a unique name. So one of the names we're using is going to be $label1, and another unique name that we're going to be using is $label2. Now, $label2 is virtually identical to $label1 in this case. The text is a little bit different. This time we're saying hello world dash the second label instead of the first label. And then the position is a little bit different too. It's 100, 100 instead of 100, 50. So the second label is going to be placed beneath the first label. And then just to make things interesting, I decided to add a completely different type of element to the window. And that's a text box. So let's take a look at how the text box works. Just like labels, text boxes are objects that have to have a unique name, and I'm calling this one text1. We could call this anything that we want. It doesn't have to be called label or text. You can use any name that you want. I just like to use the element type and then a number to help me keep track of the various elements that are going into my GUI interface. At any rate, I'm creating a variable called $text1, and I'm setting that equal to a new object of type system.windows.forms.textbox. So we're creating a text box. Now, when we create a text box, we don't have to pre-populate that text box with any text. But in this case, I am. So the words text box are actually going to appear in the text box. You'll see what that looks like in just a moment. And just as I did with the labels, I'm setting auto size to true. And then I'm also giving this a position. So whereas the second label had a position of 100, 100, I'm placing my text box at 100, 200. So we'll have one label on top, a label in the middle, and then a text box on the bottom. Then I drop down to my Draw Forms section, which you can see right here. And this is identical to what we had in the previous script. I haven't changed anything. Then we drop down to the Create the Form section. And whereas before we just had this line right here that added label 1, you can see that we've got two more lines. We have a line to add label 2, and then we have a line to add text 1. So as you can see, this form that we're creating is modular. The basic form remains the same regardless of what we're doing. But then we can create all of these different elements, and then we simply add those elements to the form. So that's how forms work in PowerShell and .NET. So let's take a look at the application that we've created. I'm going to go ahead and switch over to PowerShell, and I'll run the script. And this one is 10-2.ps1. And now you can see what the script looks like. So here's our first label. It says hello world dash the first label. Here's our second label. It says hello world dash the second label. And you'll recall that the first label was at position 100, 50. The second label was at position 100, 100. That means that the second label is placed lower down on the form than the first label is. And then we have the text box, which you can see right here. And I placed this at position 100, 200. So it's much further down in the window than the two labels are. And you also notice that this text box is pre-populated with the words text box. And we could easily erase that and type whatever we want right here. And there's one more thing that I want to show you. So I'm going to go ahead and close this out. And I'll switch back to my script. And in most applications, text boxes aren't pre-populated with text. You can pre-populate a text box, especially if you're trying to help the user out and you want to give them a default value that you think they're probably going to be able to use, but you don't have to pre-populate a text box. So let me show you how to get rid of that pre-populated text. I'm going to scroll up to my text box section, and all we have to do is comment out this line right here. The $text1.text equals quote text box quote. This is the text right here that gets pre-populated into the text box. So if we got rid of this text or deleted the line, or in this case commented out the line, then that is going to empty out that text box so that it's no longer pre-populated. So if I go ahead and run the script again, you can see that now the text box doesn't contain any text right off the bat, but we can still type anything that we want to in the text box. So that's how you go about adding additional graphical elements to a PowerShell GUI application. Hello and welcome back. In this video, I want to continue my discussion of the PowerShell GUI by showing you how to create a button and how to define the action that will occur when that button is clicked. Now, before I do, I want to take a quick step back and show you something from the script from the previous video. So let me go ahead and open up File Explorer, and I'll go to my scripts folder, and let me open up 10-2.ps1. Now, the thing that I wanted to show you is that we don't necessarily have to use objects where they're defined. So what do I mean by that? Well, if you take a look at this section right here, define labels, you can see that I've defined label 1 in this section right here. And then I defined label 2 just beneath that in this section right here. And then I came down here and defined a text box. But it wasn't until a lot later in the script where I actually used those elements that I had defined. So I come way down here and I add the labels and the text box to my form. So the point being that you can define labels and text boxes and other elements anywhere in a script that you want. You don't necessarily have to add them to the form immediately. And that point might seem subtle or relatively unimportant, but it's going to be super important with regard to creating a button and making that button respond to a click. So with that said, let me go ahead and close this out. And I'm going to open up 10-3.ps1, which is the script for this video. So here's the script. And the bulk of the script is going to be very similar to what you've already seen. So I begin by loading my assemblies, just as we have in the previous videos. Then I come down here and I define a button click function. And I'm going to come back to that in just a moment. The next thing that I have is my draw form section, and that is identical to what you've seen in the previous videos, except for the text line right here. This still says hello world, and that's an oversight on my part because I had changed the window title in one of the previous videos. I think the new title that I gave it was My PowerShell GUI application. I'll just go ahead and make that change in the interest of being consistent. So let me save this. So then I come down and we have a section where we're creating label 1. And this is really similar to what we've done in the previous videos. We have label text that says click OK to see the hello world text. And this is going to appear on the screen basically just as an instruction. That's the only thing that it exists for. And you can see that we're positioning that instruction at position 100, 100. Then I have a second label, which I'm defining right here. And I'm calling this one label 2. And this one displays text saying hello world. And I'm positioning at 100, 200. Then I come down here, and this is the first point at which we're really doing something new. We're creating a button. And like any other object that we create for use on a PowerShell GUI, a button has to have a unique name. And I'm calling this one $button1. And I'm setting that equal to a new object of type system.windows.forms.button. So we're creating a button object, and then we add attributes to that object, beginning with the button location. And you can see that I'm placing the button at position 249, 132. And we can also set the button size. And this one actually does control the size of the button. Right now, I've got the button set to 80 pixels by 20 pixels, which you can see right here. But I could make that larger or smaller as determined by my needs. What made me decide on this particular size was that I've labeled the button My Button. So there's text on the button that says My Button. And size 80 pixels by 20 pixels was just big enough to accommodate that text. So that's what made me decide on this particular size. Now, a lot of what I've done up to this point with regard to setting up a button should look familiar, because these two lines right here are essentially the same thing that we did in setting up a label. Also, this line right here is essentially the same as what you would have for a label. The only thing really different that we've done so far is in this line right here, we set a button size. But we've got one more thing that we have to do that's a little bit different, and that is to define a click action. So I define my click action right here by using $button1, that's the button name, .add_click. And then we have a parenthesis and a pair of brackets. And whatever appears between those brackets is what is going to happen when the button is clicked. Now, you could embed a PowerShell commandlet right here, or even a series of PowerShell commandlets. What I've done instead is I've made a call to a function. So let me go up to the top, and you can see that I've got a function right here. And my function is called display hello world text. And that's the same function name that I'm calling right here as my button click action. Now, interestingly, my function only has one line, $form.controls.add, and then label 2. So I've defined label 1, label 2, and button 1 elsewhere in the script, but I'm not actually adding label 2 to the form until somebody clicks a button, because when somebody clicks a button, then this particular function is going to be called, and this function tells PowerShell that we want to add label 2 to the form. So then if I go down to the bottom of the form, then the only other thing that we have is the section for creating the form. And you can see that in the create the form section, we're adding label 1, we're adding button 1, but you won't see any occurrence of adding label 2. The only place that we're adding label 2 is within that function, because we don't want the label 2 text to appear unless somebody clicks that button that we've set up. And then, of course, the last two lines are meant to display the form on the screen. And those are lines that are going to exist anytime that we create a form in PowerShell. So hopefully all of that's clear. Let's go ahead and load the script and just take a look at this. So I'm going to switch over to PowerShell, /10-3.ps1. And here's what happens when I run the script. So you can see that we have a line of text. Click OK to see the hello world text. And that's the line of text that's associated with label 1. If I switch back over to my script, you can see $label1.text equals, click OK to see the hello world text. So that's where that's coming from. We also have our button right here. And you'll recall that I placed the text my button on the button. And if I scroll down just a little bit, you can actually see where I did that. So here's the my button text right here. So that's where the text that appears on the button came from. And you'll notice the label 2 text doesn't appear anywhere on the form. Now, if I click the button, then PowerShell is going to call that function, and then that function is going to tell PowerShell to display label 2, which displays the hello world text. So if I click on the button, then we see the words hello world. And hello world is associated with label 2, which you can see right here. And label 2 only gets added to the form once I click the button. So that's how we set up a button for a PowerShell-based GUI application. In this video, I wanted to wrap up my lesson on PowerShell GUI interfaces by showing you how to create list boxes. More importantly, I wanted to show you how to create a simple GUI-based application using PowerShell. So in doing so, the script that I'm going to be using is going to be a little bit more complicated than what you've seen in some of the earlier videos. Even so, it still sticks to the same basic logic as what we've been using. Now, having said that, one of the things that I've tried to stress throughout the previous videos is that there's a certain process to building a GUI-based application in PowerShell. For example, you have to begin by loading the necessary assemblies. Once you've done that, then you begin creating the elements that you're going to use on your form. And when I say elements, I'm talking about things like labels, text boxes, buttons, and list boxes. And there are other types of objects as well, but we're not going to get into those in this course. And then once you've defined all of those objects, then what you do is you add them to the form. And you can also remove objects from a form, and you do that on an as-needed basis based on the needs of your application that you're building. So that's what we're going to be doing in this script. Even though the script is longer and more complex than some of the other ones that I've created, we're still following the same basic logic. We're going to define a series of objects, and then we're going to add those objects to the form, and we're also going to periodically remove objects from the form as the script progresses. So before I open up the script itself, I want to show you what the script does, just so that you can get a feel for what it is that we're doing. So I'll go ahead and run the script now. I'll type /10-4.ps1. And here we have our script. So what we're doing is we're getting a list of the virtual machines that are running on a Hyper-V server. And you'll notice that we have a message, please select a virtual machine from the list. And I'll go ahead and pick a virtual machine. I'll click OK. And then I'm taken to another screen, and it shows me some statistics from that virtual machine. I can see that the virtual machine is running. I can tell how long it's been up, the memory assigned to the virtual machine, and the number of virtual CPUs that are assigned. And when I'm done reviewing this information, I can click the return button, and I'm taken back to the main screen where I can pick a different virtual machine. So before I open up the script, let's just take a second and look at some of the elements that make up this particular application. We have a label right here that says, please select a virtual machine from the list. And as you'll recall from the previous videos, a label is just a block of text. We also have two buttons on the screen. We have an OK button and we have a cancel button. The OK button is what we used a second ago. It's what took us to the screen that showed us the virtual machine statistics. The cancel button ends the application. I'll go ahead and click that. And the application closes. Let me reload the application. Then we have this big text window that lists all of our virtual machines, but you'll notice the virtual machines are clickable. So what we really have here is a list box. So I make a selection, I click OK, and then I'm taken to the screen that shows me the virtual machine statistics. And there are a few other elements going on here. We have a message, your selected virtual machine, and then :VM4. And so this is a label. The label is used to display this text. And then we have a box that displays all of the virtual machine information. And then we have another button, the return button. So we're defining three different buttons, OK, cancel, and return. We're defining a couple of labels. We're defining a list box. So that's just the basic elements that go into making up this very simple application. So now that I've shown you what the application looks like, let me go ahead and cancel out of it, and I'll open up the script. Now, given the length of the script and the fact that so much of the script mimics what we've already done in the previous 3 videos, I'm not going to go through this line by line. This would be an extremely long video if I did. But I do want to show you some of the basic sections in the script, and I also want to show you some of the things that are new that we haven't done in some of the previous videos. So the first thing that we're doing is loading the assemblies up at the top, and this is identical to what we've done in some of the previous videos. Next, we have a section display the main screen, and you can see that this is a function. So I'm going to come back to this a little bit later on. Then we have return button click action, and we have another function. So again, because this is a function, I'm going to come back to it. Then we have OK button click action, and yet another function. So we'll go ahead and move on down. So now we get into the main body of the application, and you can see that this first section here allows us to define all of the objects that are going to be used. So the first object that we're defining is label 1, and we have a misprint here, define label 2. This should be define label 1. I'll go ahead and save that. And it's just a comment, but we want it to be accurate, and this one is define label 3, should be define label 2. And the reason why those comments were off is just because I've restructured the script a few times while I was creating it. So define label 1. As previously mentioned, a label just displays a line of text on the screen. And you can see the label text right here, please select a virtual machine from the list. And we actually saw that when we ran the script. If I run the script, you can see right here, please select a virtual machine from the list. So that's label 1. Next we have label 2. And label 2 displays the text, your selected virtual machine. And that text is displayed on the second screen. So if I pick a virtual machine and click OK, you can see right here, your selected virtual machine, and it won't let me highlight it, but just above my mouse pointer, your selected virtual machine, and then we see the virtual machine name. So that's label 2 that is displaying that information. Then we have another section, define output box. So the output box is where all of the virtual machine information is displayed, and all we're doing at this point is defining the output box. We're not actually putting anything inside of it just yet. Then if I come down just a little bit, we have define list box, and we're calling this one list box 1, and a list box is something new to this video. We haven't created a list box before, so let's take a look at what we're doing. So we're creating a variable called $listbox1, and we're setting that equal to a new object, and the object is of type system.windows.forms.listbox. So we're creating a listbox object, and we're calling it $listbox1. Now, as you'll recall, when we created other types of objects, we defined the object, and then we added attributes to that object, and we're doing the exact same thing here. We're adding a location attribute right here. We're adding a size attribute, and we're defining a height attribute, which is the height is going to be 80 pixels. So then, once you create the list box, you have to put something in it. And that's what this code down here does for us. And you can see I put in a comment, this code populates the list box with virtual machine names. So how are we doing that? Well, I'm creating a variable called $virtual machines. And I'm setting that variable equal to get-vm computer name Hyper-V. So what the command that's highlighted in blue right now does is it goes out to my Hyper-V server, and it runs the get-vm command, which retrieves a list of all of the virtual machines that are running on that server. And then it takes that list of virtual machines and it writes it to a variable called $virtual machines. So then the next line sets up a for each loop, and this for each loop runs for every $vm in $virtual machines. So in other words, the loop progresses one time for each virtual machine in the list of virtual machines. So that's what these variables are. $vm represents an individual virtual machine, the next virtual machine in the sequence, and then $virtual machines equals the list of virtual machines. So we're looking at all of the virtual machines in the list. So for each one of those virtual machines, what we're going to do is we're going to add the virtual machine name, which you can see $VM.name. So we're adding the virtual machine to $listbox1. And you might have noticed this void right here. All that does is it suppresses some of the output that this command would otherwise generate, just so that we can control the way that our application looks. So what we've done is we've created a list box and we've populated that list box with a list of virtual machines. So let's go ahead and scroll down a little bit and take a look at what else we're doing. So the next thing that we have is define button 1. And you can see in the comment that this is the selection screen's OK button. Remember, we have 3 buttons. We have an OK button, we have a cancel button, and we have a return button. So right now we're working with the OK button. And everything that we have here is what you've seen in previous videos. So we set the button size, we set the button location, we set the button's background color, and then the button text indicates OK, so we're putting OK on the button. Now the important thing here is the button click action. So let's take a look at what happens when we click on the button. So when the button's clicked, we have a variable called $chosen item, and we're setting that equal to $listbox1 selected item. So we're taking the item that was selected in the list box and we're adding that to a variable called $chosen item. Then once we do that, we're calling a function called display vminfo, and we're passing the variable chosen item to that function. So in other words, when we run the script, we're picking an item off of the list. For example, I select VM3, I click OK, I'm picking that item off of the list, and when I click OK, then what's going to happen is the name of that virtual machine is going to be added to the chosen item variable and then passed to the display vminfo function. When I click OK, that function initiates. So let's take a look at that function. I'm going to scroll back up to the very top of the script and let's find the function. We have display main screen, return main screen, and here's our display vminfo function. And you can see that this function is configured to accept the $chosen item variable. So we're passing the chosen item to the function. So let's take a look at what we're doing here. Here's something that I haven't talked about in any of the previous videos. So I have $form.controls.remove. Now normally when we're assembling a form, we're using $form.controls.add to add an element to a form. But here we're actually taking elements off of the form. So why are we doing that? Well, let me switch back to my script. So here's my script. I've got a virtual machine selected, and when I click OK, the screen clears and it takes me to the screen that shows me the statistics for the virtual machine. Unfortunately, there's not a graceful way of clearing the screen because we're working in a graphical environment, so we can't just use the CLS command to clear the screen. So what we have to do is use $form.controls.remove to remove the various elements. And then by removing those elements, we're clearing the screen, and then we can go in and add other elements on an as-needed basis. So what are we doing? We're removing listbox1, we're removing label 1, and then we're removing button 1 and button 2. And then we're refreshing the form. Without that form refresh, you'll never see those items actually removed from the form. So this $form.refresh line is really important. So then let's go down in the function a little bit further. We have add type assembly name system.windows.form, so we're adding the necessary form. Then we have to get the virtual machine information. So here we're setting a variable called selected VM, and we're setting that variable equal to get-vm. That's the commandlet to retrieve virtual machines. And we're retrieving those virtual machines from our Hyper-V server. And then rather than specifying a virtual machine name, we're using the variable chosen item because that chosen item variable holds the name of the virtual machine. So then we're creating a few other variables. $name equals selectedvm.vmname. So we're creating a variable called $name that's going to hold the name of the virtual machine. And we're doing some similar things below. $state is going to be equal to the selected virtual machine state. In other words, is the virtual machine running? Is it off? Then we have $runtime equals selectedvm.uptime. we're creating another variable called $memory, and we're setting that equal to selectedVM.memoryAssigned. And then one last one, we're creating a variable called $CPU, and we're setting that equal to the selected virtual machine's processor count. So we're retrieving all of these attributes directly from the Hyper-V server for the selected virtual machine. Now remember, at this point, we haven't actually displayed any of this information yet. All we've done is create variables to store this information. And you'll notice that the next section is called Create Text. We're still working within the same function. So I'll go ahead and scroll down. And what I've done is I've created a variable called outputbox.text. And I'm setting that equal to vmstate plus $state plus, and then you'll notice some weird looking codes right here. We have a backward apostrophe R, backward apostrophe N. That's essentially the new line code. Backward apostrophe R is return, backward apostrophe N is new line. And for whatever reason, a lot of times you'll find that you have to use both together. You can't really get away with using just one or the other. Sometimes it works, sometimes it doesn't. It's kind of one of those flaky things with PowerShell. So essentially what I'm doing is I'm creating a string holding various blocks of text, vmstate, VM uptime, runtime, memory assigned, and then I'm also adding those variables that I declared so that I've got this string that contains runtime, memory assigned, and all of these other elements. Then I'm setting $label2.text equal to your selected virtual machine, and then I'm adding $chosen item, which is the name of the virtual machine. So remember, up to this point, all we've done is declare variables and populate variables. Now we actually get to display some things. So remember what I said about when you're going to populate a form, you have to use $form.controls.add followed by the object that you want to add to the form. And that's exactly what we're doing in this section right here. We're adding objects that we've already defined to the form. So what are we adding? We're adding label2, and label2 was the text that says your selected virtual machine and then lists the virtual machine name. We're adding $output box, and as you'll recall, $output box contained a big block of text that gave all of those statistics for the virtual machine. And then we're adding button 3. So button 3 was the return button. And then we reach the end of the function. So let's go back down to the main body of the script. And so far we've just talked about button 1 because button 1's click action called the display VM info function, which is what we just looked at. And not surprisingly, we also have a section where we define button 2 and button 3, which I just mentioned button 3 because we added button 3 to the form, button 3 being our return button. So let's talk about button 2. Button 2 is set up in the exact same way as any other button. The important thing that we have to look at is the button's click action. So that's controlled with this line right here. So we have $button2.add _ click. We're defining the click action. And what we're going to do if somebody clicks on this button is to close the form, and that's done with $form.close. And you can see that the text that appears on that button is cancel. So if somebody clicks on the cancel button, the form closes and the application shuts down. And then the last button is the one that you saw referenced in that previous function, and that is button 3. And button 3 is the return button. You can see right here, we're printing the text return on the button. So this button's click action calls a function called return-main screen. So let's take a look at the return main screen function. I'll go ahead and go up to the top of my script and let's find that function. So we have the display main screen function right here. Let's go down. And here's the return main screen function. So what are we doing here? We're removing some elements from the function. What are we removing? Well, we're removing the output box, we're removing label 2, and we're removing button 3. So remember, we don't have a clear screen action. So if we want to clear the screen, then what we have to do is to remove all of those elements from the form. And then we have to refresh the form using this line right here. Then at that point, we call the display-main screen function. Because once we've removed everything and we've blanked the form, we need to populate that form with something. And that's where the display main screen function comes into play. And that's up here at the top. And it's the very first function that is defined within the script. So what does this function do? Well, we have $form.controls.add listbox1. $form.controls.add button 1, $form.controls.add button 2, and $form.controls.add label 1. So what this function is really doing is it's taking all of those elements that make up the main screen of the application and it's placing them on the form. So we have label 1, that was the line of text that tells us to choose a virtual machine. We have button 1 and button 2, that's the OK button and the cancel button. And then our list box, which is the list of virtual machines. So this function is causing all of that to be displayed. So now let's go down to the main body of the script. And the last thing that we did was look at the click action for button 3. And you can see that this is the end of the object definition section. So then we have code to draw the empty form. This is very similar to what you've seen in some of the other videos. We've also defined some key press actions. So we have an action for if somebody presses the enter key. We have an action for if somebody presses the escape key. And again, this is the same as what you saw in the previous 3 videos. And then down at the very bottom, we have populate the form. So we have 3 lines here. The first one is display main screen. And we looked at that function a few minutes ago. That's the function that adds the basic elements to the form, the 2 buttons, the label, and the list box. And then we have these very last 2 lines, and these are what caused the form to be displayed on the screen. So I know that's a lot to take in, but hopefully what you gathered from this is that even as your PowerShell-based GUI applications become more complex, they still follow the same basic logic. You create a form, you define some objects that will eventually appear on that form, and then you add and remove objects based on the needs of the application that you're creating. So that's how you work with list boxes, and that's how you create a GUI-based application in PowerShell.
As strange as it may seem, Windows does not come with the latest version of PowerShell installed, and you can't even get the latest PowerShell version through Windows Update. In this lesson, I want to show you where you can download the most recent PowerShell version, and I'll talk about some of the things that you can only do in PowerShell 7. My topics of discussion in this lesson include installing PowerShell 7, ternary operators, pipeline chain operators, null coalescing operators, and parallelization.
One of the interesting things about PowerShell is that your system may not be running the latest version of PowerShell, even if you've installed all of the available updates. Let me show you what I mean. Right now, I'm running Windows Server 2022, and I'm going to click on the Start button and go to Settings. And then from there, I'm going to click on System and About. And you can see that this particular machine is running Windows Server 2022 Standard, and it's running version 21H2. And right now I've got all of the available updates installed on this machine. Even so, it's running an older version of PowerShell, and I'm honestly not sure why Microsoft does this. I've never seen any sort of official explanation, but there are newer versions of PowerShell available than what come pre-installed with Windows. So let's take a look. I'm going to go ahead and close this out, and then I'm going to switch over to PowerShell. The way that you find out what version of PowerShell you're running is by typing get-host, and then the pipe symbol, and then select -object, and version. And you can see that this particular machine is running PowerShell version 5.1.2. The interesting thing about it is that, as I mentioned, this machine is fully up to date, and as of the time that I'm recording this is the current version of Windows, so I'm not running an old version or anything like that. Even so, PowerShell 7.x has been around for quite some time, and yet we see that Windows comes with version 5.x pre-installed. So let's get the newer version of PowerShell. I'm going to go ahead and close this out, and I'll open up my web browser, and I'll go to Google. I'll go to PowerShell 7 download. And this article instructs you to go to GitHub, but actually we have links right here. So I'm just going to click on PowerShell 7-2.1-Win x64 MSI, that's the 64-bit version. And I'll click Open File. And we can close the web browser. And I'm taken to the PowerShell 7 x64 setup wizard. I'll click Next. And now I'm prompted for an installation path. I'm going to go ahead and go with the default path of c:/program files/PowerShell and click Next. And now I see some prompts where I can add PowerShell to the path environment variable. I can register with Windows Event Logging Manifest, and there are several other options that are available as well. I'm just going to go with the defaults for right now and click Next. And you'll notice that one of the things that's new is we have this checkbox to enable updating of PowerShell through either Microsoft Update or through WSUS. And you can enable that by simply selecting this checkbox. There's also an option to use Microsoft Update when you check for updates. So both of those checkboxes are selected by default. I'm going to go ahead and leave those selected. I'll click Next and Install. And the installation process is finished. I'm going to go ahead and select this Launch PowerShell checkbox and click Finish. And so this is what PowerShell 7 looks like. I'm going to go ahead and make this bigger. So this is PowerShell 7, and you can see right up here it gives us the version number. But if we wanted to check that version number, we could do the same thing that we did earlier. Git-host, type symbol, select object, version. And you can see that we're running 7.2.1. So let me go ahead and close this out. Now the big question is, what happens to the previous version of PowerShell? Now I have to admit, the first time that I installed PowerShell 7, I assumed that it simply overwrote the previous version. But it doesn't. Both versions are actually on your system at once. So let's take a look at that. I'll click the Start button, and here's PowerShell 7. I'll launch that, and you can see that this is PowerShell 7. But then if I click the Start button, and I click on this icon right here, we have the original version of PowerShell. And I'll go ahead and check the version. And we're still on version 5 for that window. So we have version 5 and version 7 running side by side within Windows now. But at any rate, everything that I've shown you in this course up until this point will work just fine on version 5. The techniques that I'm going to be showing you in this lesson are all dependent on PowerShell 7. That's why I went ahead and installed it. But for everything else in the course, you don't have to worry about PowerShell 7. It will work just fine on PowerShell 5. So that's how you install PowerShell 7. Hello and welcome back. In this video, I want to show you how ternary operators work in PowerShell 7. Now, ternary operators make it a lot easier to do comparisons in PowerShell. I did an entire video on comparative operators. I'm talking about things like -EQ for equals, or -GT for greater than, or LT for less than, and there are several others. Now, a lot of times, if you're going to be working with comparison operators, there are going to be several lines of code that are required, and you can absolutely do that. But what ternary operators do is it makes it possible for you to do a comparison using a lot less code. I'm going to show you a couple of examples of how that works. So let's go ahead and get started. And I want to begin by showing you the normal PowerShell way of doing things. In other words, the pre-PowerShell 7 way of doing things. So what I'm about to show you will work in PowerShell 5. So let's go ahead and get started. I'm going to begin by declaring a variable, and I'll call this $A. And I'm going to set this equal to normal. So if I output the contents of $A, I see a text string that says normal. Then the next thing that I'm going to do is I'm going to declare another variable called $health. And I'm going to set $health equal to @ brackets, and then $true equals the system is healthy, and then semicolon, and then $false equals the system is unhealthy, bracket. So then what I need to do is to evaluate my variable $A. So the way that we would do this is by saying $health, and then bracket $A dash EQ normal, bracket. So what are we doing here? Well, we began by setting $A to normal. So here we're checking to see if $A is equal to normal. That's $A dash EQ normal. So if $A is equal to normal, then that's going to return a value of true. If $A is not equal to normal, it's going to return a value of false. But remember, we're doing this in relation to a $health variable, which you can see right here. And we already set $health equal to all of this. And we said that if $health is equal to true, then we'll display the system as healthy. If it's set equal to false, then we're going to display the system as unhealthy. So let's go ahead and press enter, and hopefully I haven't made any typos, and we see that the system is healthy. So if I were to go back in and set $A to something else, and we could have really set it to anything other than normal, and I run that command again, I get a message saying that the system is unhealthy. So this is a way that we might do error trapping inside of a script. Maybe we have a variable, $A or something else, that is designed to reflect the health of the system, and then I use lines of code similar to what you've seen as a way of interpreting that variable and reporting whether or not the system is in a healthy state. So I'm just throwing that out there as an example. Now, as you saw, this required some fairly complicated coding, but in PowerShell 7, we can use ternary operators as an alternative, and we don't have to do things in quite such a complex manner. So let me show you what I mean. Let me go ahead and clear the screen. And what I'm going to do is do the exact same thing that I just did, but I'm going to use ternary operators instead of the old PowerShell way of doing things. So I'll begin by setting $A equal to normal, just like I did before. So then what I'll do is I'll say $A dash EQ, and remember, dash EQ is a comparison operator. We're not assigning a value to a variable here. And then normal. So we're checking to see if $A is equal to normal. Then I'm going to enter a question mark, and then an apostrophe healthy. And I could type the system is healthy. I'm just shortening things here. And then colon, apostrophe, unhealthy, an apostrophe. So I'll go ahead and press enter, and I get a result of healthy. So what we're doing is we're checking to see, is $A equal to normal? If it is, then we're displaying the word healthy. And if $A is not equal to normal, then we're going to display the word unhealthy. So that's all we're doing here. So just to show you that this is indeed what's going on, I'm going to set $A equal to something else. And I'll press enter, and we'll check the value of $A, and it's set to abnormal. And let's run our ternary operation again. And now I get a status of unhealthy. So that's how that works. In this case, I was checking the value of a text string. I was checking to see if $A was equal to normal. But the same technique can also be used with numerical values. And we don't even have to use variables if we don't want to. We could do something really simple like 10-GT20. So we're checking to see if 10 is greater than 20, which it's not. So question mark, yes, colon, no. So if 10 is greater than 20, we'll see yes. If it's not greater than 20, which it's not, we should see no. And I get a result of no. And if I change the value of 10 to something else that is bigger than 20, maybe I'll change it to 30. Now we should see a value of yes. And we do. So that's how ternary operators work in PowerShell 7. Hello and welcome back. In this video, I want to talk about pipeline chain operators. Now, the PowerShell pipeline is one of those concepts that I introduced very early on in this course. It's the idea that by supplying the pipe symbol, you can take the output of one PowerShell command and feed it into another command as input. So let me show you an example of this. I'll type get-process, the pipe symbol, and then select -object name. And if I were to press enter, we get a list of all of the names of the processes that are running on this machine. So why did we get that? Well, the get-process command, when it runs by itself, retrieves a list of all of the processes. And you can see that there are a number of them. But when I append the pipe symbol and then select object name, that tells PowerShell that we want to take the output of the get-process command and then feed it into the select object command, which acts as a filter and tells PowerShell that we're only interested in the process names. We're not interested in all of this other stuff. That's why when I press enter, we get a filtered view of the output. So that's how the PowerShell pipeline normally works. Now in PowerShell 7, there's something called a pipeline chain operator. And this works just a little bit different than what you've already seen. So let me go ahead and clear the screen and I'll show you how this works. What I'm going to do is I'm going to repeat the same command that I just typed, but I'm going to make one very small change to this. I'm going to backspace to where the pipeline is, and I'm going to add a second pipeline. So we have get-process and then two pipe symbols, and I know it can be a little bit hard to tell on the screen, but these two pipe symbols are right next to each other. There's no space in between them. So we have get-process, two pipe symbols, and then select object name. So let me show you what happens when I press enter. So as you can see, the output from this command is the same as if I had just typed get-process. As a matter of fact, I'll do that now. So you can see it's the same. So why is that? What happened? Well, what this command does is we have get-process, we have the double pipeline, and then we have select object name. Now, clearly the first half of this command ran, get-process, because we did indeed get a list of processes. You saw that just a second ago. But then the filtering portion of the command never executed because the list of processes wasn't filtered so that it only displayed the name. We got the full list of processes and all of the supplementary data that goes along with it. So in PowerShell 7, when you see the double pipeline like that, what we're essentially telling PowerShell is that if the first half of the command succeeds, which in this case the first half is get-process, then if the first half succeeds, we don't run the second process. So that means that the select object name portion of the command, which was the second half of the command, that was totally ignored. That never ran. So because get-process succeeded, select object name was never run. Now, at first this seems kind of silly, but we can actually use this to our advantage. I've seen some people use this to produce custom error messages. Let me give you an example of that. What I'm going to do is backspace over select object name, and I'm going to replace that with a write host statement. And I'll just say write host, an error has occurred. So let's take a look at what's going to happen here. So PowerShell is going to try to run the get-process command right here. Then it gets to the pipeline operators, and it knows that if get-process succeeds, then every bit of this needs to be ignored, so that will never run. If, on the other hand, get-process fails and it generates an error, then this is going to run. So in other words, if the get-process command fails, then we're going to see our custom error message. If it succeeds, then that error message is never going to be displayed. So if I press enter, we get the list of processes and no error message. But let's shake things up a little bit. Let's repeat the command and let's introduce an error. I'm just going to add an extra S to the end of process so that now it's misspelled, it's no longer a valid command, and it will produce an error. So let's take a look at what happens. I'll press enter and we get the normal PowerShell error, which is everything that you see in red right here. Get process, the term get process is not recognized as the name of a cmdlet function script file, or executable program, check the spelling of the name, or if a path was included, verify that the path is correct, and try again. So this is the normal term not recognized error that you see all the time in PowerShell. But then just below that, we have an error has occurred. So PowerShell displayed our custom error message. Now, we could actually go a whole lot further with this, because in this case, we simply followed the double pipeline symbol with a right host statement. But we didn't have to use right host. We could put anything we want right there. We could do a function call instead. So we could actually do some sort of error handling. We could say, okay, if an error occurs, then call this function, and then that function will handle the error. But in this case, in the interest of keeping things simple, I've just got a right host statement. And incidentally, you can also create your own error messages in PowerShell. I did an entire video on custom error messages, but there was one technique that I never touched on in that video, and maybe I should have, but it's a little late, so I'll go ahead and show you that now. What you can do in PowerShell is you can do write error rather than write host. And you'll notice that when my write host command executed, the output was in white. If I change this to write error and I run this, then we see write error colon an error has occurred, and it's in red, so this is a legit PowerShell error. I'm not just changing the color of the text or anything like that. We're actually generating an error that PowerShell can be made aware of. At any rate, let me go ahead and clear the screen. And there's one more thing that I want to show you. So far, the way that the pipeline chain operators have worked is that if the first half of the command succeeds, then the second half is ignored. If the first half fails, then the second half executes. But you can do kind of the opposite of that too. You can make it so that if the first half succeeds, then the second half runs. If the first half fails, then the second half is ignored. So let's see what this looks like. I'm going to say write host. And just for the sake of clarity, I'm going to shake things up and do something a little bit different than what I've done before. I'm going to do quotation marks and say this is the first half of the command. And then I'll do my double pipeline, and then I'll do write host. This is the second half of the command. So if I press enter, the first half of the command was perfectly valid. So it executes, which you can see right here. And then because of the double pipeline, the second half is totally ignored. That's this portion right here. So if we want both halves to execute, then what we need to do is change the double pipeline to a double and sign. And I'll go ahead and do that now. And let's rerun this. So now we see this is the first half of the command, and then this is the second half of the command. So the first half succeeded, and then the second half was run, and it succeeded as well. So what happens if we introduce an error into the first half of the command? Well, let's try it. I'll go ahead and repeat the command, and I'm just going to introduce an error by adding an extra T to the end of host. I'll press enter, and now nothing but an error, because the first half of the command failed, so the second half of the command was completely ignored. So that second half of the command only runs if the first half succeeds. So that's how pipeline chain operators work in PowerShell 7. Hello and welcome back. In this video, I want to show you how null coalescing operators work in PowerShell 7. Now this is something that only works in PowerShell 7, so you're not going to be able to use this in earlier versions. The idea behind a null coalescing operator is it's a way of checking to see if a value is null. The basic idea is that you present two values, one on the left and then one on the right. If the one on the left is null, then the one on the right is the one that gets returned. Otherwise, if the one on the left isn't null, then it's the one that gets returned. Now, I know that probably sounds just a little bit confusing, so let's take a look at an example, and hopefully that will clear up any confusion. So what I'm going to do is I'm going to begin by declaring a variable. I'll call this $A. And I'm going to make $A null. So I'll say $A equals $null. And if I look at $A, you can see that we get nothing back because it's a null value. Now let's set up another variable. I'll call this one $B. and I'll give $B a numerical value. Let's make it equal to 100. So if I look at $B, we can see that it's equal to 100. So we have two variables at this point. We have $A, which is null, and $B, which is 100. So now let's use a null coalescing operator with these two variables. So what I'm going to do is I'm going to type $A, and then I'm going to type $B. So we're looking at $A, and we're looking at $B. I'll go ahead and press enter, and you can see that the result is 100. So remember what I said earlier about how this works. We're looking at two values, one on the left, one on the right. The one on the left is $A, the one on the right is $B. If the one on the left is not null, then that will be returned. If the one on the left is null, then the value on the right will be returned. So in this case, $A is on the left and it's null, so PowerShell returned the value on the right. Had $A been set to something other than a null value, then the value of $A would have been returned. It doesn't matter if the number that's assigned to $A is bigger or smaller than the value that's assigned to $B. That's irrelevant. The only thing that matters is that $A is on the left and it contains something other than a null value. So let's take a look at how this works. I'll set $A equal to 0. And then I'll do the same thing again. $A $B. This time I get a result of 0. And the reason why I got that is because the value on the left, $A, is not equal to null. It's something other than null. And this also works with string data. I could say $A equals S. And if I do the comparison again, $A $B, I get a value of S because $A is not a null value. So it doesn't actually matter what we put in $A, it only matters that it's not null. If it is null, then we get the value of $B, whatever that happens to be. So if I were to set $A back to null, and I do the comparison once again, then this time I'll get the value of $B, which is 100. So that's how that works. Now there's one other technique that I want to show you before I end this video. The technique is called null coalescing assignment operators. It's extremely similar to null coalescing operators, which I just showed you, but the difference is that a value actually gets assigned. So let's take a look at how this works. I'm going to clear the screen, and we'll start out the same way that we did last time. I'll declare $A equal to null, and I'll declare $B equal to 100. Now, as you'll recall, if we were to just use a null coalescing operator, $A $B, then we'll get the value of $B because $A is set to null. Now, what a null coalescing assignment operator does is it looks just a little bit different. We add an equal sign after the two question marks. And what this tells PowerShell is that if $A is null, then it's going to be assigned the value of $B, whatever that happens to be. So rather than $A being null, when we execute this statement, $A is going to be set to 100 because that's the value of $B. So I'll go ahead and actually let me backtrack here. Let's take a look at the contents of our variables before I do this. So I'll say $A, which is null, $B is 100. So then I'll say $A equals $B and press enter. Now, if we look at $A, we can see that $A has been set to 100. And if we look at $B, that should still be 100 as well. So what we've done is we've essentially said, if $A is null, then make $A equal to $B. That's what a null coalescing assignment operator does. So that's how null coalescing operators and null coalescing assignment operators work in PowerShell 7. Normally, when you run a PowerShell script, the steps within that script execute in sequence. This is called serial execution. In other words, step 1 runs, then step 2 runs, then step 3 runs, and so on and so forth. You never have a point at which you have multiple steps running at the same time. Now, normally that's absolutely fine, but if you've got a long-running script, you can speed things up by allowing multiple steps to run at the same time. This is what's known as parallelization. And in PowerShell 7, it's actually possible to set up a loop so that steps in the loop execute in parallel. So let me show you how this is done. As you can see right now, I've got PowerShell 7 open. I'll make this just a little bit bigger. And I'm going to open up a script that I wrote ahead of time. This is script 11-5.ps1. So here's the script. And right now, I've got all of the parallelization code commented out. So you'll notice that there's a comment on this line and a comment symbol on this line. So those two lines aren't going to execute when I run the script. So let's take a look at what the script does, and then I'll step you through it. Let me switch back over to PowerShell, and I'll run the script. So all this is doing is it's retrieving the state for several virtual machines that are running on my Hyper-V server. So you can see VM1 is running, VM2 is running, VM3 is running, VM4 is off, and VM5 is running. Now in this case, you'll notice that those results were returned pretty quickly. If you weren't paying attention to how long it took, let me go ahead and just run this again. And we got the results almost instantaneously. And the reason for this is that retrieving the state of a virtual machine is a very simple process that doesn't require a lot of resources. Plus, I'm in a lab environment, and there's nobody on any of these systems except for me. So you're probably not going to see a lot of difference in speed from one version of the script to the next. Even so, I wanted to at least show you what I'm doing and give you a before and after. So with that said, let me go ahead and switch back to my script, and I'll show you how this works. So here's my script. The very first line of the script sets up a variable called $VMs, and I'm setting that equal to VM1, VM2, VM3, VM4, and VM5. Each one of these is the name of a virtual machine that's running on my Hyper-V server. So then I'm setting up a loop. I'm taking the contents of $VMs, which is VM1, VM2, VM3, VM4, and VM5, and I'm using that as input for a for each loop. So you can see I've got $VMs, type symbol, and then for each object. And then I've got my bracket to start the loop. So what are we doing in the loop? Well, right now, we're just running one step inside of the loop, this line right here. So we've got get-vm, that's the PowerShell commandlet to retrieve information about a virtual machine off of a Hyper-V server. And then we've got $_. And what this is essentially just telling PowerShell that I want to use the name of the virtual machine that's being supplied to the for each object loop rather than supplying a literal virtual machine name. So when the loop runs for VM1, then we're going to run get-vm VM1. When the loop gets to VM2, then this command is essentially going to say get-vm VM2, and so on and so forth. And then we've got -computer name Hyper-V because we're retrieving the virtual machine information off of a Hyper-V server that just happens to be called Hyper-V. And then I've got a pipe symbol followed by select object, name, comma, state. So I'm retrieving each virtual machine's name and its running state. And if I switch over to PowerShell, you can see that we have the virtual machine name in this column by my mouse pointer, and we have the virtual machine state in the other column. So that's where that's coming from. So that's the script. That's what it does. It assembles a list of virtual machines. It builds a loop based on that list of virtual machines, and then for each virtual machine in the list, it retrieves the virtual machine name and the virtual machine state. That's it. That's the whole thing. Now, as I mentioned at the beginning, right now this is running in serial. So we're processing VM1, then when that gets done, we're processing VM2. We wait for that to complete, then we process VM3. We wait for that to complete. We process VM4. We wait for that to complete, and then we do VM5. So that's what we call serial execution. Now, as I mentioned at the beginning, because we're using PowerShell 7, it's actually possible to run all of these at the same time and make this loop parallel. So let me show you how that's done. So what I'm going to do is I'm going to comment out the line that sets up the loop. That's the second line right here. And I'm going to remove the comment symbol from the line below it. Now, as you can see, these two lines are identical, but with one exception. The line that I just uncommented has the word -parallel. The existence of the parallel parameter tells PowerShell that we want to deal with all of these virtual machines at the same time. We want to process them in parallel rather than doing serial processing and looking at each virtual machine one at a time. Now, there's one other thing that we've got going here. We've got a throttle limit. Now, you don't have to set a throttle limit, but sometimes it can be a good idea to set a throttle limit just so that PowerShell doesn't consume an excessive amount of resources. So I'm setting the throttle limit to 5, which means that we won't process any more than 5 virtual machines at a time, which I've only got 5 virtual machines in this case, so that's really all that we need. So let me go ahead and comment out this closing bracket, and I'm going to remove the comment from the closing bracket where we've appended a throttle limit. So let me go ahead and save the script. I'll switch back over to PowerShell and we'll run the script. And there isn't really any visible difference because this isn't a long running script, but if this were a script that would normally take a long time to process, you would likely see a dramatic difference in the amount of time that it took the script to complete. So that's how you handle parallelization in PowerShell 7.
Thanks again for joining me. I hope you enjoyed learning the material as much as I enjoyed making these videos for you. By watching these videos, you've learned how to use PowerShell for a variety of purposes. Keep in mind, however, that in spite of the many hours of content, these videos really only scratch the surface of what is possible. If you have technical questions regarding PowerShell, then I recommend checking out Microsoft's online documentation. Microsoft documents every single PowerShell commandlet, and the Microsoft website is by far the best place to go for information on all things PowerShell. Thanks again for watching.